A, because the section A is actually not easy, especially question number 3 and question number 4. Although there are 4 questions, right, but I think 3 and 4 will probably take up quite a fair bit of time. So allocating 1.5 hours should be comfortable for this to complete this section A of NJC. ASR has been bad most of the years. I think ASR, or at least AJC, okay. I mean, SRJC usually it was okay, but AJC had been like setting very difficult papers since the beginning of H2 math. So I would not be surprised that in 2020 this year ASRJC's paper is going to be pretty hard. We did one together, right? And remember, it was a pretty tough paper. But I think we should just start with this NJC section A as soon as possible, so that you guys, if you are for those of you who are joining me tonight, right, we can quickly finish this and you can continue to study for your next paper. Because I don't think tomorrow is math, right? I cannot recall any math paper. That any of my students telling me that tomorrow has any math paper. So most likely your math paper should be on Friday. I think most people's, if their math paper is this week, paper 2 should be on Friday or maybe Thursday. But then the rest of you should be having your paper 2 only next week. So we'll be doing a revision, doing a practice on NJC paper 2 statistics on this Friday. So let's take a look at this question together. Okay, first question here. This is an okay and easy question. We have a piecewise function fx, and we have so here, this one here, right? It is. I'm not sure whether you know the term. Okay, so this is a piece. Oops, that's a very, very bad spelling. So this is a piecewise function. There are two kinds of function that is mentioned in this question. A piecewise function, because for each x, this function is defined piecewise. There are 2 pieces that totally define this function fx, and here we see this function behaving in a periodic manner also. Periodic function we have learned since secondary school. Your common periodic functions will be like sine, cosine, tangent. And when we know that, for example, for sine, the period is 2 pi, so whatever angles that are given to me, we just need to plus or minus the period. You'll go back to the same thing, which is like what we are seeing here. The difference between what you are experiencing in H2 math as compared to your secondary school is that in H2 math, they will give you a new piecewise function, where that means one that you probably have not seen before. You spot the period and then just react according to how you have reacted to sine, cosine, tangent in your secondary school. Which means that in this question here, the period is 3. Which means that every time when I have a number, plus or minus 3, it is going to go back to the same thing. I repeat again, just like in your secondary school, when you know that 2 pi is the period for sine, any angles that is going to go into sine plus or minus 2 pi will get back will give you the same output through sine. So like for example here, part 1, we are looking at f of 44 over 3. 44 over 3 is 14.6 something. 14.6 something is outside the domain of this piecewise function. So I want to get a number that is between 0 to 3 so that I can make use of this piecewise function. So 44.3, which is 14.6 something, is outside 0 to 3. It is too big, so I'm going to just keep minusing 3. If I were to minus 3 once, that means if I were to take let's say 44 over 3 minus 3, I am going to be getting f, this is going to be equal to 35 over 3. 35 over 3 is 11.6 something, which is still going to be too big. So I'll just keep minusing and minusing until when I get a number that is inside here that is between 0 to 3. And if you were to keep doing that, you will end up with f of 8 over 3. 8 over 3 is 2.6 something. So it is going to be between 0 to 3. And now 2.6 something, we know that it is specifically between 2 to 3. So I know this is going to be 12a divided by x. X is 8 over 3 minus 4a. And this is going to get us a half a. Okay, for this 2 marks question, it is very easy to get 2 marks. And I think it's good because after you have done your statistics, coming to question number 1, I would think that this is going to be a good warm-up and encouragement for us to continue to finish up section A as quickly as possible to get a good paper 2. But I do believe that for a lot of you, you are going to be scoring higher for your paper 2 as compared to your paper 1. So please, you're just like what Hello was saying, right? Please make sure that you go all out for your paper 2, okay? We make sure that you score as high as possible for paper 2. I have told my tuition class a few weeks ago that I had students who didn't do exactly that well for paper 1, you know, for example like 40 plus, 50 plus, but because paper 2 they managed to push to 80 plus, and I have students who pushed to a 90 plus for paper 2 prelim, but then in the end, right, they actually got a B on A overall, okay, because paper 2 was pushed like extremely high. Next, part 2, we are going to try to sketch the graph from -3 to 3. It is the same thing. Periodic graph, when we are trying to sketch it, we will sketch one period, just like how you have sketched one period for sine. Then you extend to the left and extend to the right to complete the full set of domain that is requested. So for this, let me do a sketch of one period first. So for one period, I'm going to go for 0 to 3, where especially the domain that I'm supposed to sketch will involve 0 to 3. So for this, yes, I do think it is definitely possible to do well for paper 1. In fact, today some of my students were telling me that paper 1 went pretty okay. Not the best possible experience, okay, because for a lot of us, right, we didn't expect that paper 1 can be so demanding in terms of the second half of the paper. So sometimes we may need to rush a little bit more. But so far, the feedback that I've gotten today was pretty good. Yeah, it is definitely possible to do well for paper 1. In fact, I think for A levels, paper 1 is going to be the key, not paper 2. Well, paper 2, because most people will be doing considerably well, so the playing field is very even. So for those people who are getting A or B for the entire A level H2 math, right, I believe the key usually lies in paper 1. Okay, let me draw a slightly longer x-axis. So we have this. From 0 to 2, it is a linear line with a gradient of A, and it passes through the origin. So we have from here all the way, let's say until here, until 2. So when x is equal to 2, the output is 2a. Let me indicate the coordinates of this point, 2 and 2a. Then after that, this part of the curve from 2 to 3, I will probably let a be a positive number, plug it into the calculator to get a rough idea of the way this curve is. Or you can see, I mean, if you are seeing this as one of the standard graph, referencing it to 1 over x, where it is also pretty easy to sketch this. It has a horizontal asymptote of x is equal to minus 4a, sorry, y is equal to minus 4a. So from, and when x is equal to 2, when x is equal to 2, I have a 6a minus 4a, and the output happened to be 2a also. So it's going to be starting from here. It will tend down to the horizontal asymptote, which is below the x-axis, but we are stopping at 3. Hang on, let me just do a sketch. Whoops. Let me sketch it down from 2 to 3. Because when x is equal to 3, we have 12a over 3, which is 4a minus 4a, so it will become 0. So we'll have a point here, 3, 0. And because it is strictly less than 3, so I'm going to add in a hollow dot here. Oh, no, actually shouldn't. I shouldn't add in a hollow dot because it is bigger or equal to 3, and when it is 3, I will go for this. So when this is 3, when x is equal to 3, it is going to be, oh, it is going to repeat, so it's going to be here. So here should be a solid dot. And this part is going to repeat on the left hand side. So we have this and a straight line down, which is going to occupy 2 units. So from here to here, it is going back 1 unit, which means that here from 0 going back 1 unit is -1 and 2a. Then here we are going to go back 3 units, so this is going to be -3 and 0. And bigger or equal to -3, we are going to have a solid dot here. Okay, so this is our graph of fx for x to be between -3 and 3. And my origin is here. So this is part 2 and part 3. Really? I thought I mean, Claire here says that section A is quite easy. I thought this section A is not easy, because I thought question number 3 and question number 4, they are really very, very tricky. Especially, I'm just imagining a student doing 3 and 4 in the exam. It is I feel that these 2 questions, right, they are quite intimidating as prelim questions, especially if you started off with stats, then after that you go to pure math, right? That means 3 and 4 will be the last 2 questions. And what if you are left with just like maybe half an hour or 45 minutes? When doing question that is like 3 and 4, right, will really push you to rush. And I don't think it is that easy to do 3 and 4 fast. Let's see it together, okay? How we can process and do question number 3 and question number 4. Anyway, here we are supposed to do an integration from -2 to 2 of fx. So if I can view this integration as area under the graph, it is basically going to be -3 is here, -1 is here, so -2 is going to be somewhere here. -2 all the way until 2. 2 is going to be here. So we are trying to find the area under the graph from -2 to 2. And I am going to break up this region, okay, into 3 parts. From here to here. What I see is a trapezium. So I'm going to try to apply the area of trapezium formula. Okay, that means this part, where it is a trapezium. And this is -1. So area of trapezium is going to be half times height. Height is from here to here, which is 1, times sum of parallel sides. Parallel sides will be the y coordinate of this point and the y coordinate of this point, which we have. It is 2a. So for the y coordinate of this point, we are going to work on f of -2. So -2 is not within this region, and because of the periodic nature of the function, we will +3 to get it back into this region. So it's the same as f1, -2 plus 3, f1, and f1 is going to be equal to a times 1. So this is going to be equal to a, which means that this point here will be -2 with a y coordinate of a. This will be the height. This will be one of the parallel sides. So one side is a, the other side is this, which is 2a. Then plus another area that I'm going to be working on will be this area here. As for this area, we don't really have the graph for this area, this region, but we do have the graph for this region here. And we know that this region is exactly the same as this region. So for us to find the area of this, let's try to find the area of this region, which is bounded by the curve y is equal to 12a over x minus 4a. Okay, it is from 2 to 3, we have this graph. So this will be integrating from 2 all the way until 3. It is going to be the same as this region of 12a over x minus 4a. Then plus the last region will be this region here. This region is very, very simple to calculate. It is just a triangle. So half times base times height. Half times base is 2. Height is 2a. So half times base times height here. This is 3a. So we have 3 over 2a. Plus this is easy to integrate. We have 12a ln modulus of x, and then minus 4ax. Lower limit is 2, upper limit is 3, plus this is going to be equal to 2a. So 2a plus this is equal to 7 over 2a. Then plus, let me substitute this in, we will have a 12a ln of 3 minus away, substituting this in, we have a minus 12a. Then this minus away, substituting 2 in, we have a 12a ln of 2 minus away 8a, then plus 2a. Consolidating all the common terms together, we will get a 12a ln 3 minus 12a ln 2, which is a 12a ln of 3 over 2, and for all the rest of the terms, adding them together will give me a minus half a. Okay, the area of these three regions, when I add them together, is going to help us to represent the integration from minus 2 to 2. Okay, this is question number 1. Okay, I have to agree that 1 is an easy enough question. We can definitely be doing this question faster during the exam. Let's take a look at question number 2. Question number 2 is a differential equation question. It is going to start to get a little bit tedious, but I don't think this is that difficult a question also. You know, like what we have been talking about, right? When we are doing differential equation, the first thing that we need to do to solve a differential equation is to identify the kind of differential equation that we are dealing with. Because in our syllabus, there are only 2 ways to solve differential equation, which is to treat it first, not 2 ways to solve differential equation. There are only 2 kinds of differential equation for us to solve. The first kind are simple differential, where dy dx or d square y dx square is in terms of just x, like this. Or the variable separable kind, where it will involve x and y, but not any expression that involve x and y. There must be expressions that can be re-expressed as one function of x multiplied by another function in terms of y. So anyway, we have a simple differential here. This is 2 over square root of 1 minus 4x squared. This is a simple differential because d square y dx square is in terms of just x. So in order for us to find dy dx, is just a simple integration of this. So integration of 2 over square root of 1 minus 4x squared. This will give us dy dx, which I am going to just rewrite this. It's not super necessary, but if I were to just strictly see this as fx f prime x, then fx is going to be 2x. Then f prime x is going to be equal to 2. So this, we have a sine inverse. Sine inverse of 2x plus an arbitrary constant. I'm going to go for c. Then to find y, we will integrate this one more time. So y is going to be integration of sine inverse of 2x plus c. Plus c dx. And to integrate sine inverse 2x, I don't think there's any standard results, and probably for you guys who are already starting to do your prelims, the moment you look at this, I know you should be able to identify that you should be able to decide that integration by parts is going to be the strategy to integrate sine inverse 2x. So I'm going to apply integration by parts by letting u be equal to sine inverse 2x and letting dv dx be equal to 1. So du dx is equal to 2 over square root of 1 minus 2x squared, which is 4x squared. Then v integrating this is going to be equal to x. So integration of sine inverse 2x will be uv. So we have x sine inverse of 2x minus integration of v du dx, which is going to give us a 2x divided by square root of 1 minus 4x squared dx. Let's not forget about the plus c, which will become, when I integrate this c, it will become cx. Let me just add in the arbitrary constant now, okay? So later when we integrate this, I'm not going to add in any more arbitrary constants. So I'm going to just assume that d is going to be the overall arbitrary constant, Or if you don't want to add d now, it is also okay to add d later. I don't think it matters that much. As long as in your final answer, you have this extra arbitrary constant because of the process of integration here. So this is already done. I'm not going to touch it. As for this, let's make use of fx, f prime x. Fx will be 1 minus 4x squared. F prime x will be minus 8x. So minus, I'm going to bring it in. But I need an 8, so I'm going to divide by 4 outside. So that I can have a minus 8x. Then 1 minus 4x squared to the power of minus half dx plus cx plus d. So this is x sine inverse 2x plus 1/4. Integrating this, we have a 1 minus 4x squared to the power of positive half divided by positive half, then plus cx plus d. This gives us a x sine inverse 2x plus half square root of 1 minus 4x squared plus cx plus d. Okay, this is going to be my fx. So according to the question, we are supposed to find fx. So here we go. This is fx. In fact, right, I don't know for you guys if you have done if you have already done part 2, if you have already sketched a graph. I don't know whether you are aware of small details that is in this graph. Oops, this is not fx yet, so sorry. I realize we have not done part 1, so let me do part 1. For part 1, we are supposed to find fx. So for fx, we know that it has a minimum point at the origin, which means that we know f0, this is going to be equal to 0, and we know f prime 0, this is also going to be equal to 0. Okay, this will tell us that it is a stationary point, minimum point is a stationary point, and it passes through the origin, f0 is equal to 0. Let me make use of this first to solve for c. So for this, f prime 0 is equal to 0, which means that sine inverse of 0 plus c, this is equal to 0. This tells me that c is equal to 0. So for fx, we know it is x sine inverse of 2x plus half square root of 1 minus 4x squared plus d. And f0 is equal to 0. This is given to us by the question. So letting x be equal to 0, this will be 0 plus half of square root of 1 minus 0 is going to be 1. Then plus d. So we know d is equal to minus half. So therefore, we know what is fx. Fx is equal to x sine inverse 2x plus half square root of 1 minus 4x squared plus d, which is minus half. And we're going to try to sketch this in part 2. So let me try part 2. In part 2, in order for me to sketch this, we will definitely be pressing this into the GC, into our calculator. Let me show you what I have gotten from my calculator. I pressed this and I got this. Okay, this was what I've gotten on my calculator. Let me make it a little bit bigger. So I've gotten this. I'm going to be sketching this, which means that since x is between minus half and half, okay, so we will have 2 hollow dots here. So we have 2 hollow dots here, 1 hollow dot, the other hollow dot. For any endpoints, we need to indicate the information, the details about the endpoint. So we need the coordinates of the endpoint. So when x is equal to minus half, let's try to find it first. This is where the detail comes. When x is equal to minus half, so we will let all the x here be equal to minus half. So we have x, which is minus half. Then sine inverse of 2x. So sine inverse of 2 times of minus half minus 1. Then plus, when this is minus half, 4 times of minus half square is going to be 1. 1 minus 1, this is going to be equal to 0 minus half. It is this sine inverse of -1 that I'm curious how you guys process this sine inverse of -1. Well, I'm not going to elaborate too much on this, but because there are actually multiple possible, there are multiple solutions to sine inverse -1 by right, okay, there are multiple angles that will give sine to be equal to, when it is thrown into sine, it is going to give you a -1, right? If you were to look at the sine graph is supposed to be like this. So there are a few different angles that will give you a -1 as the output, correct? But for sine inverse, you need to refer to your MF26 in order for you to determine exactly which angle you need to be writing down when you have a sine inverse, cosine inverse, and tangent inverse. And the place that you're going to see from your MF26 in your formula sheet is going to be this. Let me show you. I think I have a screenshot for it. Now let me see whether I can retrieve the screenshot. Hang on. Let me see whether it is possible. Okay. Yep. Yep. In an MF26, right, you actually have this. And I need to highlight to you guys, especially you're going to be having your A-levels. I personally feel that details that are like this are very, very crucial. So you can see in MF26 that sine inverse x is supposed to be between -half and half. That is why here, if I were to evaluate, this will be -half. And sine inverse -1, I'm going to go for a -pi/2. Okay, out of the different possible angles, we'll go for this. So this -half, which will then give me a pi/4 -half. Similarly, for the other end, that is when x is equal to half. So f half. This is going to be equal to half sine inverse of +1. And again, I'm going to be making use of this. Here, this part will be 0 again. This is going to be equal to this. And we will have a half. And since the output of sine inverse is also going to be between -half and half, for this sine inverse 1, it is going to be equal to pi/2, then -half. So this will end up with a pi/4 -half also. Okay. So now I am ready to draw the graph. My graph will look something like this. Based on my GC, I can already see the shape of the graph. X-axis, it is going to be this. Okay, let me try one more time. It will pass through the origin. Then, yep, like this. We should pass through the origin because when x is equal to 0, this is going to be 0. This is going to be half minus half. So it will pass through the origin. And here it must be a hollow dot. Here it must be a hollow dot because the question says that it is strictly bigger than -half. The output is equal to pi/4 -half. And half. And output is also pi/4 -half. So they're on the same horizontal line. Okay. When there's a chance next time, maybe we can talk a little bit about why is there this restriction for sine inverse. But one reason for this restriction, right, let me just very quickly talk about it. It is because sine inverse is the inverse function of sine. When if you were to go for the usual sine function, it's going to fail the horizontal line test because the sine function is that wavy shape. Definitely a horizontal line is going to cut it at more than one point. So you need a restriction on sine so that it can become a one-to-one function so that sine inverse exists. And that is why that restriction that we see in our MF26 is to make sure that sine inverse, cosine inverse, tangent inverse exist. Okay? Okay, you can go and explore a little bit. I mean, you can go and explore them a little bit more. But if we have a chance next time, maybe we can just discuss a little bit more about this idea of principal angles, that is, MF26. Next, let's take a look at question number 3. We will probably be spending a bit more time on question number 3 and question number 4 tonight. It's not like it's very, very difficult, but 3 and 4, they are just a little bit more. Okay, 3 is more tedious, 4 is somewhat like unexpected. So question number 3, we are given that part 1. We are not supposed to be using our calculator, and we are given that x plus yi, this is equal to square root of 8 minus 6i. When we are dealing with a complex number question, it is good to think of how we can re-express any complex numbers into either the x plus iy form or re to the power of I theta form. For example, this, right, there will be some people who will think that, hey, isn't this already the x plus iy form? No, because of the square root, so overall it has yet to become the x plus iy form, the real plus I imaginary form. And that is why when you see something that is like this, even if you feel that you are pretty stuck in doing this question, you can have a primary aim, okay, which is to find ways to re-express everything that you are seeing into the real plus I imaginary form first. So we have already achieved that on the left hand side, but right hand side not yet. And one way to achieve x plus iy form in the right hand side is to try to square both sides, which will then give us x plus yi. This is going to be, sorry, let me just rewrite. It will be x plus yi square. And the right hand side now, it is this. We're in the real plus I imaginary form, but now not the left hand side. But we can definitely expand the left hand side. We can't do much for this, but we can expand the left hand side. This will be this plus 2xyi minus y square. This is equal to 8 minus 6i. So let's try to rearrange this so that it is going to be the real plus I imaginary. Imaginary is going to be this, then I. This is equal to 8 minus 6i. So now we can match the real to the real, the imaginary to the imaginary. And please remember, whatever that we are trying out here, right, we are trying to re-express both the left and right hand side into the real plus I imaginary. I'll repeat again, this can be your primary goal in doing any complex number questions, which you decide that you're going to exploit from the perspective of Cartesian form. We just do the rearrangement first. So now from here, we know that x squared minus y squared is going to be equal to 8. And we can see that 2xy, this is equal to minus 6. I'm going to call this equation number 1. And for this, if I were to make y the subject, this is minus 3 over x. I'm going to call this equation number 2. And I'm going to substitute equation number 2 into equation number 1, which will give me an x squared minus y squared, which is minus 3 over x squared. This is equal to 8. And if I were to multiply throughout by x squared, we'll get an x to the power of 4. 8x squared, if I were to shift it over to the left hand side, minus 8 squared. Then minus, this will be 9. It's equal to 0. And treating this as a quadratic equation in terms of x squared, we can factorize this to x squared plus 1. And x squared minus 9. This is equal to 0. And because x squared plus 1 is always going to be positive, so x squared minus 9 is going to be the one that is equal to 0. This tells me that x is going to be equal to, x squared is going to be equal to 9. So x is going to be equal to plus or minus 3. And when x is equal to, for example, minus 3, y will be equal to minus 3 over minus 3. Y is going to be equal to 1. And when x is equal to positive 3, y will be minus 3 over positive 3. This is going to be equal to minus 1. Okay, we have already solved for this, but this tells me an information that I'm going to try to write it down here. This tells me that square root of 8 minus 6i are going to be these two complex numbers. One is minus 3 plus I. the other one is going to be equal to 3 minus I. In fact, they are just negative of each other. For example, I can see this as minus of 3 minus I. Okay, so I'm going to see this as plus or minus 3 minus I. Okay, I can understand why you are wondering why will this be 2 marks. If you were to look at the solution wise, I don't think I can cut this down that much. Okay, but the thing about this question, right, is that it is very, very standard. So I was just thinking maybe what NJC was thinking of, right? I mean, I don't know what happened to, I mean, they might have prepared their students with a lot of revision and practices for this particular kind of question. That is why when it comes to something that is like this, where you basically just go through the same process, I think maybe that is why they didn't allocate that much marks for this. And if you were to look at, I think, the A-level papers 2 years ago, A-levels, they are usually pretty fair and generous in terms of giving marks. But I think that there was one year, I think it was 2 years ago, when A-level gave something that was like this. They also gave it as a 2 marks question. So NJC could be trying to simulate that particular slightly more stingy A-level question also. But other than that, I cannot really think of why such a long solution, right, will be a 2 marks question. By the way, Alvin, this z to the power of 5, right, is no longer in the syllabus. So you cannot be applying this for this particular question. Okay, so z to the power of 5 will be totally irrelevant if you are referring to using the De Moivre's theorem. So we have to use this particular strategy that I have just mentioned, which is a very, very standard strategy, like really very, very standard. So now we have this as the result, although the question didn't say, but we will probably be making use of this result. We have a w squared plus 2iw minus 9 plus 6i. This is equal to 0. And according to the question, we are supposed to solve for w. This is a quadratic equation. We can either go for completing square, or I can just simply apply the quadratic formula to solve for w. But that's what some people didn't expect also, I think. So if complex number has not come out in your paper 1, please take note of this. This has been very, very popular in the last few years of prelim, because A-level also said this, I think 2 years back. We're giving a quadratic equation with complex coefficient, and then students are expected to be able to solve this directly by completing square or the quadratic formula. So we have a minus b minus 2i plus or minus square root of b square, so 2i squared, minus 4ac, c is minus 9 plus 6i. Okay, so we have this over 2a, a is 1. So we have a minus 2i plus or minus square root of 2i squared. This is going to give me a minus 4. Then this, it will give me a plus 36. This gives me a minus 24i. This divided by 2. So we have a minus 2i plus or minus square root of this gives me a 32 minus 24i divided by 2, which we can also try to rewrite. I mean, we can also try to factorize out 4. So it will be 4 of 8 minus 6i. Okay, and now 8 minus 6i has surfaced. So we'll probably be making use of this result for this. This divided by 2, which gives me a minus 2i plus or minus square root of 4 is 2. Then we have a square root of 8 minus 6i. We will now definitely be making use of the result from the previous part. Square root of 8 minus 6i. this divided by 2, which is equal to minus I plus or minus square root of 8 minus 6I. So we know this is plus or minus 3 minus I. So this is minus I plus or minus 3 minus I. So we have two possible answers, minus I plus 3 minus I, or minus I minus 3 minus I. So we have 3 minus 2I. This is one of the answers. And this is going to be minus 3. Then we have a minus I plus I. It will disappear. So the other possible answer will be minus 3. Okay, two answers for part 2. Okay. Then B. Let's try 3B. 3B is, 3B is not related to 3A, so let me erase 3A, okay? Okay, let me remove this too. So 3B. 3B, I want to show that if Z1 is a root of this equation, then minus Z1 is also going to be a root. So if Z1 is a root to this equation, we know that Z1 to the power of 4 minus P Z1 square plus Q, this is equal to 0, because Z1 should satisfy this equation. So, and Z1 to the power of 4, we can actually rewrite it as minus Z1 to the power of 4. It's going to be exactly the same thing, correct? Then minus away P. This, because of the square, we can also rewrite this as minus Z1 square. Then plus Q, this is equal to 0. Okay, they are exactly the same. This tells me that Z1 is a root, or is also a root. 1 mark. And part 2. Part 2 is going to be a little bit more tedious. Part 2, first we want to verify that this Euler form is going to be the root of this equation. So for this Euler form, since it's a root to this, since we want to verify that it is a root, let's try to substitute this into the left hand side and show that it is equal to the right hand side, which is equal to 0. So we have 3 e to the power of I pi over 6 to the power of 4. Then minus 9. Then 3e to the power of I pi over 6 square plus 81. Let's try to see whether it is going to be equal to 0, because if it is, then we have verified that this is a root to this equation. So this is going to be 3 to the power of 4 e to the power of I 4 pi over 6. 4 pi over 6 is 2 pi over 3. Then minus away 9. This we have a 3 square e to the power of I 2 pi over 6. This gives me a pi over 3. Then plus 81. 3 to the power of 4, this is 81. 3 to the power of 4 is 3 square times 3 square, so 9 times 9, 81. Then this, I'm going to try to re-express this into the Cartesian form, which will be cosine of 2 pi over 3 plus I sine of 2 pi over 3. Then minus 9 times 9, this is 81 also. Then this cosine of pi over 3 plus I sine of pi over 3. Then plus 81. So we have 81. Cosine 2 pi over 3 is minus half. Plus I sine 2 pi over 3 is square root of 3 over 2. Then minus 81. Cosine pi over 3 is half. Then sine pi over 3 is square root of 3 over 2 plus 81. So we have a minus 81 over 2 and a plus I of 81 square root of 3 over 2 minus 81 over 2. Then minus I of 81 square root of 3 over 2 plus 81. This can be cancelled to become 0, and this will also disappear to become 0. So this whole thing is equal to 0. Therefore, we can say that 3e to the power of I pi over 6 is a root to the equation. To this equation. Yep, we took care of that also, because just now we wrote this. For this, right, just now we saw that square root of 8 minus 6i, this we saw that this can be equal to 3 minus I. We also saw that square root of 8 minus 6i, this is minus 3 plus I, which is minus 3 minus I. So just now we have derived at this. We have derived that W was minus I plus or minus square root of 8 minus 6i, which we rewrote this as plus or minus of 3 minus I. Oh, as in like you're talking about the plus minus, right? In the end, even if you try to work out all the plus minus, you're going to have only two possible solutions. Because plus minus, in the end, you're still going to be having just plus minus 3 minus I. You cannot work out four possible permutation. So in the end, although it is plus minus times plus minus 3 minus I, you will still get an overall 2 possible plus minus 3 minus I. Okay, so I'm assuming that's what you meant, because it is supposed to be plus minus times plus minus 3 minus I. But if you were to consolidate all this together, you are just going to have a plus minus 3 minus I. For example, right, if you have a plus minus 3, no matter how you try to multiply and times, right, in the end you are just going to have, yes, you are going to have 4 possible results, but 2 of them and 2 of them are going to be the same. So in the end, you are going to get a plus or minus 3. Okay. Okay, let me continue with this. In the next part, hence the question says, hence express this as a product of two quadratic expressions in Z. Two quadratic expressions in Z with exact real coefficients. The thing is, this equation over here, right, this Z to the power of 4 equation, the coefficients are all going to be positive. The coefficients are all positive number. So if the coefficients are all positive numbers, that means if a complex number is a root, that means the conjugate will also be a root. Which means that since now we have verified that this is a root, this will tell me that 3e to the power of minus I pi over 6 is also going to be a root. Okay? And from here, from this one, that means we have now two roots, right? This and the conjugate will be 2 of the roots of Z to the power of 4. And from part 1, we can deduce that if this is a root, then minus 3e to the power of I pi over 6 is also going to be a root. And the conjugate of this will also be a root. So we have 4 roots. Let me write them down properly here, okay? We have already shown this, okay. So for this idea that we have currently, right, we have already verified that 3e to the power of, okay, let me write down all the roots. So the roots for this will be, we have verified, right, that 3e to the power of I pi over 6 is a root, which means that the conjugate, which is going to be 3e to the power of minus I pi over 6, will be another root. And from part 1, like what we have just mentioned, if this is a root, that means 3e to the power, minus 3e to the power of I pi over 6 must also be a root, because the negative of this will also be a root. That means the conjugate of this will also be a root, right? The conjugate of this, because like what I was saying, you are dealing with a polynomial with real coefficient. That means if I have a complex root, then the conjugate will be a root. But here, let's be a little bit careful, because I cannot just simply do a quick conjugate to this, because this is not the Euler form yet. But the Euler form will be re to the power of I theta, where r is a positive number. So, but this minus 3 is not a positive number, so we need to try to re-express this as the Euler form first. How do I re-express this as the Euler form? Minus 3 or minus 1. Okay, I can see this as, let me write it in red color, okay? So, so for this minus 3, e to the power of I pi over 6. Let me show you how we will analyze this to find the conjugate of this. So this, I can see it as minus 1, then 3 e to the power of I pi over 6. Minus 1 is very, very tricky in terms of complex numbers, because a lot of people, they don't see minus 1 as a Cartesian. But minus 1 is a Cartesian form. It is like minus 1 plus 0i. So we need to convert minus 1 into the Euler form. The quickest way is to try to visualize this on an Argand diagram. Minus 1 is going to be here. Minus 1, 0. The modulus is 1. The argument is going to be equal to pi. So for minus 1, I'll rewrite it as 1 e to the power of I pi. Then 3 e to the power of I pi over 6. 1 times 3 gives me 3. E to the power of I, by applying the same thing as indices, it is going to be pi plus pi over 6, which gives me a 7 pi over 6. And I can rewrite this as 3e to the power of minus I 5 pi over 6. Which means that now this, I'm going to see this root as 3e to the power of minus I 5 pi over 6. This is going to be my third root. And then my fourth root will be 3e to the power of positive I 5 pi over 6. They are conjugates of each other. When I want to repeat again, please make sure that you watch out for this minus 1. Okay, minus 1 is a Cartesian. So this entire form that we are looking at here is still not an Euler form. Okay, until when you re-express minus 1 into Euler and then merging it into the 3e to the power of I pi over 6, then you will get an overall Euler form. Okay? So now we have 4 roots. Let me erase this first. So we have 4 roots. Whoops, what happened? Oh no, did I erase the whole thing? Hang on, let me see. So we have now 4 roots. We have now 4 roots. It is this, one root, another root, then another root, and another root. We are supposed to re-express this whole thing as the product of 2 quadratic equations. So for quadratic equations wise, right, two quadratic expressions, that means we are looking at 2 quadratic factors. And if you were to take a look at what I've written in the theory outline for complex numbers, under polynomials, I gave a result, which is good for us to be making use of here, although it is not necessary. But the result was this: if I have a z minus x plus iy, if I have this, multiply by a z minus x minus iy. But it's very, very easy to expand. But that is why I would suggest that we memorize the result of the expansion, so that we don't need to go through the expansion every single time. We are not going to get marks for it anyway. So if you were to expand this, the result is z squared minus 2xz, then plus x squared plus y squared. So I'm going to apply this to find the 2 quadratic factors that will form for me the two quadratic factors of this, okay, by looking at the roots as Cartesian form. It's very, very easy for me to change all these roots to Cartesian form. Let me do a quick change. So this I pi over 6, this is equal to, changing this to Cartesian form, we have a cosine pi over 6. In fact, we have done it previously already, plus I sine pi over 6. So this is going to be equal to 3. Cosine pi over 6 is square root of 3 over 2, plus I sine pi over 6 is half. So we have a 3 square root of 3 over 2, then plus I of 3 over 2, which means that the conjugate e to the power of minus I pi over 6. We don't have to actually go through this because it is just the conjugate of this. This is going to be equal to 3 square root of 3 over 2 minus I of 3 over 2. So with these two, I can form my first quadratic factor or quadratic expression. Where the question asks for two quadratic expression. The first quadratic expression I'm going to form by taking z minus this, the first root. This is going to be 3 square root of 3 over 2 plus I 3 over 2. This is going to form for me one of the factors to this, right? We are using the factor theorem. Okay, because this is one of the root, so z minus this is going to give me a factor. Another factor will be z minus another root, which I'm going to pick the conjugate of the first root. So I have this minus I of 3 over 2. This, right? You can actually do a very quick expansion to get this. Like what I was saying, from here to here, right, I'm using it as a result. But if you were to do an expansion, a manual expansion, it is going to be this times this, which will give you a z square. Then this times this, which will give you a minus of x minus iy z. Then this times this, minus x plus iy of z. Then this times this, it will be plus x plus iy, then x minus iy. If you were to simplify this, you have a minus, I'm going to factorize out z, I'm going to factorize out, which means that I will have a x minus iy, this, then plus x plus iy, then z, then this times this is x squared plus y squared. So simplifying this, y and y can be, iy and iy can be cancelled. I'll be left with this 2x. Okay, then this is just this. But like what I was saying, right, this whole process here is very unnecessary because it is just a simple expansion. So most of the time, unless the question specifically mentioned about it, or else writing this yourself is not going to get you marks anyway. So my suggestion is, if you can just apply this result in the exam, go ahead and just apply this result. Okay, I have this result in the theory outline for the Cartesian, for a complex number in the Cartesian form. We're on the second page under polynomial, right? I have this result. It's very, very useful result. Not because you cannot expand it, it's just that it's going to save you time. And it will tell you that if you were to take a factor, multiply by another factor, where you are using two roots that are conjugates of each other, you're going to immediately get the quadratic factor, which is what I'm doing here. Where this is one factor, this is another factor, and these two roots are conjugates of each other. Applying this result, it is going to be immediately z squared minus 2 times of 3 square root of 3 over 2 z plus 3 square root of 3 over 2 square plus 3 over 2 square. Okay, super fast. So my first expression here is going to be z squared minus away 3 square root of 3 z plus this is going to be what? This is going to be equal to 9. I'm going to do the same thing for the other two roots. So for the other two roots, Okay, let me expand this. Let me rewrite this into the Cartesian form. So we have 3 e to the power of minus I 5 pi over 6. This is 3 cosine of minus 5 pi over 6 plus I sine of minus 5 pi over 6. So this is going to be equal to 3 of cosine minus 5 pi over 6. This is going to be equal to minus square root of 3 over 2. As for sine, this is going to be minus half. So I have a minus 3 square root of 3 over 2 minus I of 3 over 2, which means that the conjugate, which is 3 e to the power of I 5 pi over 6, is just going to be minus 3 square root of 3 over 2 plus I of 3 over 2. And we are going to make use of this result again. Let me just shift this. So we're going to make use of this result again, and we know that as long as we try to take the one factor multiplied by another factor, choosing the roots properly so that they are the conjugates of each other, we are going to get a quadratic expression with real coefficients. So the second quadratic expression this will be taking z minus the first one minus 3 square root of 3 over 2 minus I of 3 over 2, then z minus the other one is going to be minus 3 square root of 3 over 2 plus I of 3 over 2. Again, making use of the same result, we have a z square minus 2 times of minus 3 square root of 3 over 2 z plus minus 3 square root of 3 over 2 square plus minus 3 over 2 square. And this gives us a z square plus 3 square root of 3z plus 9. So we have two quadratic factors, and we are supposed to express this as product of the two quadratic factors, right? So my final answer, I can finally remove this now. My final answer for z for this express, okay, so my final answer is z to the power of 4 minus 9z squared plus 81. This is going to be the multiples of two quadratic factors with real coefficient, will be this minus 3 square root of 3z plus 9 multiplied by z squared plus 3 square root of 3z plus 9. Yep, this is the same as the sum of roots, product of roots. We're exactly the same as sum of roots and products of roots. But I'll suggest that you just simply make use of the results that I was showing you just now, because the sum of roots and products of roots, okay, actually you can also try to use that. Okay, I don't think it is going to be, but because sum of roots, product of roots, usually you will just go through one more process, because in the O level that is considered as something that is of value, so you're going to be writing down to get marks. But like what I was saying, right, if you don't plan your paper and you are writing down things that are not going to get you marks, then you probably will not be able to finish the paper, because it is not about just getting question number 3 correct. It is how you can plan question number 3 so that you have enough time to do a question that is like 4, then completing the entire question. And if you spend that few seconds trying to do the expansion or try to apply sum of roots and product of roots, and if it is going to take up significant enough of amount of time, for example a few seconds, in an exam a few seconds, I will consider it as a significant amount of time. But then you probably will run out of time to do 4, which means that you will not get marks. you're doing something that will not get you marks and then you're losing marks later on, I don't think it is very worth it. So my suggestion is to just memorize that result. Yeah, using the sum of roots and product of roots, right? It is another process. So so if you can do it fast, it is fine. But because we don't practice sum of roots and products of roots anymore in H2 math, so unless you can do it fast, or else I would not suggest that you do sum of roots and products of roots. Just use the result that I gave is already sufficient. Alvin, I because the problem is in H2 math, right, you will not be using sum of roots and products of roots. Just like in H2 math, you're not going to be using any of the the shoelace method. So because some of my students were asking me, can I use the shoelace method? I mean, of course, yes, you can. It's just that after a while, right, you don't get any chance to practice the shoelace method at all. So you will actually get slower and slower and slower after the 2 years. Then I mean, unless you continuously spend time to go and practice the shoelace method or methods that are from your secondary school, or else, right, you must at least identify that some of those methods are not very valuable in H2 math because they are very simple. I mean, I can just code a result and I can really get answers. But totally no problem, okay, Alvin, if you are going to apply sum of roots and product of roots. But what I'm trying to say is the pacing. We cannot be, I mean, when you are doing a paper, you cannot be focusing on doing one question. You must be focused on how you can complete the entire paper. It is like I keep giving this example of running 2.4 to my tuition students. Because doing a 3-hour paper is like, for example, running a 2.4. It is not like, within their 100 meters in the entire 2.4, you decide to run very, very fast and then winning all the people in the cohort, right? Then after that, because you ran out of steam, it doesn't matter whether you win that 100 meters or not. In the end, you must still be able to complete the 2.4 and get your goal for 2.4. Well, anyway, using secondary school's method is totally no problem, okay? Okay, let's look at 4. 4 is somewhat a little bit more. I don't know what to say about 4 because it is not difficult, but it's just that it requires time to think and process more than I think 1, 2, and 3. 3 is just tedious. It is not difficult also. It's tedious, it's a bit messy because of all the search form, all the Euler form and stuff. Okay, so let's take a look at question number 4. Just now I remember Claire was saying, right, that she has gotten a lot of zeros, which is true. If k is a non-zero integer, we want to first look at this. Integration from minus pi to pi of sine kx dx. This integration will be minus cosine kx divided by k. Then from minus pi all the way until pi. Maybe minus 1 over k, I'm going to take it out. Then I'll be left with a cosine kx from minus pi to pi. So it will be cosine minus k pi minus cosine of k pi. And cosine minus of an angle is the same as cosine of the angle. So we will have a minus 1 over k, and we will have a cosine k pi minus away cosine k pi. And this is equal to 0. Okay, like what Claire has just mentioned, right? This is 0, and we will be getting a few more zeros. This is actually also 0. If we were to be integrating from minus pi to pi of cosine kx dx. Okay, this is going to be sine of kx divided by k minus pi to pi. 1 over k, let me take it out. So it will be like sine kx in the square bracket. So it will be sine of k pi minus sine of minus k pi. This is simple because sine of any integer multiples of pi is going to be equal to 0. Okay, k is an integer number, and the same for this. Okay, minus k is also an integer number. Sine of any integer numbers of pi is going to be equal to 0. So I have a 1 over k of 0 minus 0, which is also going to be equal to 0. So let me indicate it here. This is equal to 0. Okay, we will be using this tool in a short while. Next, I want to show that this is equal to this, so let's try. We will be integrating from minus pi all the way until pi of sine mx sine nx. We have a very popular kind of integral these few days. I mean, sorry, not these few days. A very popular kind of integral these few years, because A-level set it in, I think, the year 2017. And even before A-level has set this, right, schools are already giving this as an integral in the tutorials and in tests and in prelims. So and after A-level has set this, it has become like super popular. So what are we going to be making use of? We will be making use of the factor theorem. With the factor theorem from our MF26 from our formula sheet. So to make use of the factor theorem, I need a 2 in front. So let me go for half minus pi to pi. And this will be 2 sine mx sine nx dx. We're making use of the trigonometric identity from my MF26 from my formula sheet. I will be able to re-express this as cosine of mx plus nx minus away cosine of mx minus nx dx. Okay, making use of the trigonometric identity that is provided to us by our MF26. This is equal to half. Let me break this up into 2 parts to analyze. So minus pi to pi of cosine m plus n x dx, then minus away half integration from minus pi to pi. Then I'll be doing a cosine of mx minus nx dx. Hang on, something seems to be wrong. Did I get anything? Did I do anything wrong for this? Sine, this is going to be cosine minus cosine. What has gone wrong? Oh, I see. Okay, I've applied the identity wrongly. So there must be a minus, this must be a minus 2. So this is equal to minus half. So this is supposed to be equal to minus half plus. Okay, it is supposed to be a minus here. So, okay, now it's correct. Then from here, what we need to do next is this m plus n. So in this question, m and n, they are positive integers, which means that m plus n will be an integer by itself. So I can see this as if it is k, which is this one here, cosine kx. K is any non-zero integer. So I can see this whole thing as if it is cosine of kx. So it is like minus pi to pi of cosine of kx dx, which is this result, and it's going to give us a 0. So this whole thing here, this part is going to be 0. Then plus half of this. Let me just rewrite this first. Minus pi and pi. Cosine m minus n x dx. As for this, because of the hint that is given to us by the question, we need to consider two possible cases. One is for m to be equal to n. When m is equal to n, what we have is going to be a half integration of minus pi to pi of cosine 0 dx is if m is equal to n, and cosine 0 is 1. So it is like half integration from minus pi to pi of 1 dx, which is equal to half of x integration from minus pi to pi, which is going to be equal to half of pi minus minus pi. So I have a 2 pi divided by 2. This is going to be equal to pi, which will give me this as my answer. I need to consider the other case, and that is when m is not equal to n. If m is not equal to n, then this is like minus pi to pi. We have a cosine of m minus n x dx, which is like kx again. Because m is not n, that means m minus n is going to be a non-zero integer. So this is going to be half of this. Using the this result over here, this is going to be equal to 0. So I'm going to be getting a 0. So from here we can now do our conclusion, which is that integration from minus pi to pi of sine mx sine nx dx. This is going to be pi if m is equal to n, and it is going to be equal to 0 if m is not equal to n. Okay, we are reacting on the spot based on what the question says. So yeah, it's like what I was saying, I don't think it is very difficult. It's just that you need time to pause and think through what this question is trying to ask you to do. And because it is, I would say it is the unfamiliarity that makes this a little bit more challenging in the exam. Or else it is not that bad, I think. And by considering the formula for this, part 2, by considering the formula for this, we are going to try to evaluate this. The formula for cosine mx plus nx. Again, we are going to make use of our MF26. Expanding this, it will be cosine of mx. Cosine of nx minus sine of mx. Sine of nx. And according to what we are supposed to integrate here, right, it is this, which is here. So let me make this the subject. So we have a cosine of mx, cosine of nx. This is equal to cosine of mx plus nx minus away sine of mx, sine of nx. And I'm going to just rewrite this as cosine of m plus n x minus sine of mx, sine of n x. Okay, now I'm going to try to apply this. Let me remove this. I'm going to try to apply this to here. Let me continue here. So we are going to be integrating it from minus pi all the way until pi of cosine of mx, cosine of nx. This is equal to integrating from minus pi to pi, making use of what we have done here. That means it is going to be cosine of m plus n x minus sine mx sine of n x dx. We should definitely break this up into two parts because of our experience from just now. We could have actually done this a little bit faster, okay? It's just I'm writing down step by step so that I can talk about my thought process also. So we have a cosine m plus n x dx. Then minus away integration from minus pi to pi. Oh no, I made a mistake. This should be a plus because I brought this over to the other side. So this should be a plus, this should be a plus. So here is a plus, here is a plus, plus sine of mx sine of nx dx. As for this, we have just analyzed m and n, they are positive numbers, which makes m plus n a non-zero integer. So we can make use of this result. So this entire thing is going to become 0. And we have this as minus pi to pi of sine of mx, then sine of nx dx. And this, we have just integrated it here. That is why my answer is going to be the same as this, which is pi. If m is equal to n, and it is going to be 0 if m is not equal to n. And that is this one. Yep. So we have done this, we have done this, we have done this. This is somewhat interesting, I thought. M not equal to n is 0. Okay, why is this 0, right? Why is the answer 0 when you have this? It's based on the first part. Like for example, just now we had this, right? Let me see. Just now we were looking at this. We were looking at this and we were trying to explain why this to this. Cosine of m minus n x. We were trying to look at this and asking ourselves why would this be equal to 0 if m is not equal to n. If m is not equal to n, that means m minus n is going to be a non-zero integer, right? Because m is not equal to n, and m is a positive number, n is also a positive number. So m minus n, it can be a positive integer or a negative integer, but it is just not 0. And from the previous part, we know k, which is a non-zero integer, when it is inside this, cosine of a non-zero integer of x from minus pi to pi is going to give me a 0. That is why we can see this. We can see this as if it is integration from minus pi to pi of cosine of a non-zero integer value of x. From the previous part, this is equal to 0. Okay? I thought part 3 is it is definitely pretty interesting, but I probably won't exactly welcome this in my exam because part 3 require quite a bit of analysis. So let me try to talk about part 3, okay, and hopefully you guys can understand what I'm trying to express about this part 3. Part 3 here, I will try to see this as if it is area under the graph. We're under the graph of y, let me write it down. Under the graph of y is equal to modulus of sine ax. Okay, I'll see this as area under the graph from minus pi all the way until pi. Okay, let me sketch out the diagram for you, okay? So if I were to analyze the diagram of this, it is going to be something like this. Let me sketch. So if I were to sketch a sine AX, it is going to be this top half, right? Then after that, the bottom half, it will be like this. And because all the x is going to be scaled by a factor of 1 over a parallel to the x-axis, so this will be pi over a, and this will be 2 pi over a. But this portion, because of the modulus, is going to be reflected up. So this portion is going to become, it's going to become like this. Okay, so this part will be no more. Similarly, if I were to continue to draw, okay, let me just draw a few first, okay? So it should be like this. This is one period, and if I were to draw another period, it is going to be the top half. Then after that, the bottom half. Let me draw one more, which is going to be the top half, and after that, the bottom half. So we can see that this is going to be, I mean, if you were to deduce, this is going to be 3 pi over a. This is going to be 4 pi over a. Then 5 pi over a, and so on. Okay, but because of the modulus, so this bottom half will actually go to the top. So you become this. So bottom half will go to the top. So you become this. Similarly, for all the rest of the parts of the graph, it's going to become this. So all this will, so this will disappear, this will disappear, this will disappear. All the way until what? All the way until the very last one, right? The very last one should end at pi, right? Because we are supposed to be integrating from minus pi to pi. So should I write a pi here? Or if I were to see this pattern, right, the denominator is always going to be a. So if I'm going to be getting a pi here, that means this part here, right, it must be a pi over a, correct? In order for me to get the very last number as pi. So how many of these humps do I have? I have 1 pi over a, 1, 2 pi over a, 2, 3 pi over a, 3. So 1, 2, 3 all the way to a pi over a, which means that in total, we're going to have a numbers of these humps, right? I say again, 1 pi over a is 1 hump, 2 pi over a is 2, 3 pi over a is the third one, which means that a pi over a is going to be the 8th hump. So there are a number of them. And we are supposed to be integrating all the way from minus pi to pi. And if you were to continue from here, it's going to be another hump, it's going to be another hump, and this is going to be minus pi over a, and this is going to be minus 2 pi over a, and all the way, if you were to do the same deduction, they are just symmetrical, which means that the other side here, right, from minus pi, which I can see this as also minus a pi over a, which is this minus pi. There will be another a humps here. And that is why for this integral that we have, right, let me erase this, okay. That is why for this integral, integration from minus pi to pi of modulus of sine ax dx. If we were to talk about the sum of all the areas, there are 2a of this. So 2a of integration from 0 to pi over a of sine ax dx. Okay, so this is going to be equal to 2a of integrating this is minus cosine ax over a from 0 to pi over a. Yep, this is the area of 1. Let me write it down here. So this is integration from 0 to pi over a of sine ax dx. Okay, like what Claire you have just mentioned here. Oops. Like what you have mentioned here. like what you have mentioned here, right? It is finding the area of 1, then multiply by 2a, because there are 2a of these humps. With a 2 is because you are integrating from minus pi to pi. So on one side there are a of them, on the other side there's another a of them. So total there are 2a of humps. In total there are going to be 2a of them, because a on this side and a on this side. So total there are 2a of the humps. So 2a multiplied by this a I can take it out, so it will be 2 times of, here we have minus cosine of pi, then minus cosine of this is 0. So this is going to be 2 of minus 1 plus 1. Okay, you will get a 4. Okay, a very interesting question, because we actually need to visualize it based on a little bit of pattern recognition, so that we can deduce that from here all the way until the very last hump there are a number of them. Okay, a little bit of series and sequences is applied here because of the pattern recognition. Yep, so this we are getting a 4, okay, based on this. And then hence the question says, so we'll probably be making use of this result. Hence the question says we are supposed to find the exact volume of the solid that is formed when the region that is bounded by this graph, which means that we have this, then after that it is going to be shifted, it's going to be translated by 1 unit in the positive y direction from minus pi to pi, rotated about the x-axis. So the volume is going to be, because this is going to be translated by 1 unit in the positive y direction, so everything is going to be above the x-axis and it is going to be rotated about the x-axis. So it is just using the same formula, which is pi integration from minus pi to pi of this modulus of sine ax modulus plus 1 square dx. Okay, this is the typical volume formula. It is integrating this entire thing square. And yes, I do find that this is challenging, because the question told us that we are supposed to find the exact volume. We can't press the calculator anyway because of the a. So to find the exact volume of this, I guess one way is to try to manipulate the expression that is given first. So the expression that is given is this. One manipulation that we can definitely try to do is to expand this. So, and what we will be expecting, right, is we'll be expecting ourselves to be making use of this result. So expanding this, you'll give me a square plus 2ab plus b square, and we will have a modulus of sine ax square plus 2 this times this modulus of sine ax and plus 1 square dx. Modulus square is the same as just the thing square. You know, the modulus doesn't really matter. So if I were to break this up, I can see this as if it is integration from minus pi to pi of sine square ax dx plus 2 times of integration from minus pi to pi of modulus of sine ax dx. And I guess that is when I'm going to be making use of the previous result, then plus integration from minus pi to pi of 1 dx. But in a JC I've never seen it before, but in a uni I do see students going into a huge rage after the exam. I mean, I can see them like really crushing the paper, then throwing it onto the floor, like literally in the exam hall, you know, just crush and then throw it onto the floor. But you guys won't get to do this. You know why? Because you're going to be submitting the question paper together with your script, so there's nothing for you to crush. This we are going to be applying the trigger identity, the double angle. So this will become 1 minus cosine of 2ax divided by 2 dx plus 2 pi. 2 pi, this we have already gotten the result, that is 4. Then plus pi of integration of this is just x, from minus pi to pi. I'm going to take out half, so half pi. Integrating 1 is x. Then integrating this is sine of 2ax divided by 2a, from minus pi to pi. Kicking the table, I don't know, I thought kicking the table is normal. Even in JCs, I see my friends kicking the table sometimes, but I've never really seen people crushing the paper, you know. I mean, in movies, I do see them eat the paper, you know, but I feel that eating an A4 size paper is very challenging to me. I don't know whether you guys have tried before, but I've seen my friends try eating an A4 size paper. I really want to puke, you know, when I see them trying to eat a full A4 size paper. So I have 8 pi here, then this is going to be pi of pi minus pi. I will have a half pi, then substituting this in, it is pi minus, I have a sine of 2a pi. Okay, sine of an integer of pi is always going to be equal to 0. So I have a 0, then minus pi. And again, when I substitute minus pi into here, sine integer of minus pi is still going to be equal to 0. So I have a 0 again. Then plus, this is 8 pi. And here I have a 2 pi. So 2 pi times pi, 2 pi squared. And this is going to be half pi. This will be pi plus pi. Oh, this is 2 pi. So plus 8 pi plus 2 pi squared. Yay, we have finished. So this plus pi, plus 1, 2 plus 1, we have a 3 pi squared plus 8 pi. So let's try this question number 5. If you have never done anything that is like question number 5, I do suggest that you try, for those of you who are able to watch the playback, right, I do suggest that you try to look through question number 5 together with me a few more times to get to know a little bit better of how to apply and execute question number 5. Because I don't think it is very difficult to understand, but I don't think we will have a lot of chance to practice a question that is like 5 in our revision package and in a lot of other papers that we have done. So, and I do see that this is a pretty important question. So please, you consider reviewing this question together with me again for those of you who are able to watch the playback. Yes, I do suggest, like what Alvin is saying here, right? Sometimes we should try to skip certain questions, especially if the question is like really very, very difficult. It is no point for us to be wasting time thinking about a question when I cannot even write anything substantial. But let's try this question number 5 together, okay, and see what we can write together. And of course, at the same time, learn how to tackle a question that is like 5 together with me. And maybe if you were to come out in your paper 2 next week, you then I've just bitten my lips. I think I'm going to get an ulcer. So hopefully, if this question were to come out in your paper 2 next week, you will be one of the few students who will be able to do this question. So question number 5. To me, it is obvious that it is a binomial distribution question, because the question says that there are X number of success out of N independent trials. The probability of success for one trial is P. So I'm going to just define for myself this binomial distribution first. So X here follows a binomial distribution with the number of trials n and the probability of success p. So for part 1, we are supposed to show that this is equal to this. In fact, this is pretty simple. But the working seems to be complicated. But if you were to try this a few times, and I'll suggest for those of you who are planning to redo this question, right, I'll suggest just trying to work through the algebra a few times so that you are used to it and you realize how easy it is actually to get these 2 marks. Furthermore, I do feel that this question can be a little bit more repetitive because I've seen this question coming out a few times already, although it is not the most popular question, but yeah, I've seen this repeatedly coming out year after year. So let's try to write down the formula for probability of x is equal to k first, shall we? So I'm going to apply the binomial distribution formula from the formula sheet MF26, and this will be n choose k. Then p to the power of k, the success, it will happen k number of times. The failure, it will happen n minus k number of times. It depends on you, but I think I'm going to try to re-express this further by writing this n choose k into the factorial notation. And I'm doing this because I know that subsequently, in order for me to try to show this expression here, I will need to rewrite n choose k, and subsequently for probability that x is equal to k plus 1, I will need to rewrite the n choose k plus 1. And to rewrite this, let me show you, it is actually based on a formula that is both in your O-level formula sheet and in your A-level MF26. It is based on binomial distribution, based on binomial expansion in your MF26. In MF26, under the section on binomial expansion for n to be positive integer, you actually see this n choose r is equal to n factorial divided by r factorial n minus r factorial. So we are going to make use of this. Let me rewrite this as this will be n factorial divided by, according to this, it will be k factorial. Then n minus k factorial. I'll leave this as it is, p to the power of k, 1 minus p to the power of n minus k. I'm going to do the same thing for probability that x is equal to k plus 1. So this will be n choose k plus 1. Yep, it is good for us to be manipulating this, like what Claire is saying, right? It is good for us to be manipulating this using factorial notation. Then p to the power of k, then 1 minus p to the power of n minus k plus 1. So if I were to re-express this according to the binomial expansion, to the n choose r in my binomial expansion, it is going to be n factorial divided by k plus 1 factorial, then n minus k plus 1 factorial. Then we have a p to the power of k, then 1 minus p to the power of n minus k minus 1. Let me just simplify this a little bit. So I have n factorial divided by k plus 1 factorial, then n minus k minus 1 factorial, then p to the power of k, 1 minus p to the power of n minus k minus 1. Okay, so I have this. Let me remove this first. So let me try to take this divided by this. So we have a probability of x is equal to k plus 1. Then this is going to be divided by probability that x is equal to k. And this will be, here, we will have a n factorial divided by k plus 1 factorial, then n minus k minus 1 factorial, p to the power of k, 1 minus p to the power of n minus k minus 1. So this is going to be divided by this expression here, which is n factorial divided by k factorial. then n minus k factorial. P to the power of, oops, did I write wrongly? Oh, this is supposed to be k plus 1. Sorry, my fault. So here is k plus 1, k plus 1. Then you'll be n minus the number of successes, which is n minus k plus 1. So here will be k plus 1. Then this to the power of k. Then 1 minus p to the power of n minus k. And now it is time to simplify this so that hopefully I can get something that is like this. There are some terms that is pretty obvious that we can already cancel away. For example, n factorial, they can be cancelled away. Then p to the power of k and this p to the power of k can also be cancelled away. And I guess 1 minus p to the power of n minus k and this n minus k we can also cancel away. Let me just write down the slightly simplified version first, okay? This, if I were to flip it up, I will have a k factorial, n minus k factorial. And this is going to be divided by k plus 1 factorial, then n minus k minus 1 factorial. And we will have a p, 1 minus p to the power of minus 1. P, 1 minus p to the power of minus 1, it will be p over 1 minus p, which is pretty good because I have a p over 1 minus p here. We're on the right track. And now the other key is how can I simplify this? I'm not sure how you guys used to be, how you guys simplify factorial notation that is of this kind of format. But my suggestion is to always break down the bigger term. Very similar but bigger term. For example, right? I have a k factorial and a k plus 1 factorial. K plus 1 factorial is the bigger term. So k factorial, I'm going to leave it. But k plus 1 factorial, I'm going to break it up into k plus 1 multiplied by k factorial, where I'll usually try to break up the bigger term. Similarly for this and this is the bigger term. If I were to break it up, it is going to be n minus k. Then after that, n minus k minus 1 factorial. And I have a n minus k minus 1 factorial in the denominator. And I have a p over 1 minus p. So now I can do some cancellations again. This will be cancelled. And this will be cancelled. And now that leaves me with what the question wants me to show, which is n minus k multiplied by p divided by k plus 1 and a 1 minus p. And in case some of you, oh, is the video hanging? It seems to be okay on my side here. Okay, anyway, in case some of you look at what I'm doing here, right, and find it intimidating, like what I was saying, you should really try to independently work this out yourself, and you realize that it is actually pretty stable. I mean, not stable. I was just reading the chat, and I was going to say that the video is pretty stable because that's the feedback I'm getting from the system. But anyway, what I was trying to say, right, is if you were to try to simplify this algebra, all this factorial yourself, you realize it's actually pretty consistent. It's not that difficult. It is just cancelling out some factorial notation. So please don't be intimidated by me doing this. Try it yourself and you understand. And even if the first time you find it a bit problematic, just try a few times and you realize the process can actually be repeated. What that is actually a bit more interesting, right, is in part 2. Okay, let me show you something about part 2, okay? We are still going to be working on this binomial distribution. But for part 2, right, we need to have an idea of two things. Number one, the most probable. The most probable is also the most likely. It is also like trying to find the mode of this distribution. The mode of this distribution is the value of x that gives the highest probability. That is why it is the most probable number of successes, because x is the number of successes. This is number one. The interpretation of this most probable is most likely. The interpretation of this is it is the value of x when the probability is the highest. The second thing that you need to know, which is not very common, I do believe that it is in your lecture notes, but I think for the new H2 Math syllabus, they don't focus so much on it, which is the graph of a binomial distribution. If you draw a graph of a binomial distribution, it actually looks a bit more like I think it is called a histogram. So let's say I have x, which is the number of trials. So for this case, right, we are looking at n to be equal to 99. So there will be 99 trials. The probability of success is going to be 7 over 9. Let me just rewrite this first. So we are looking at x that follows a binomial distribution of 99 and 7 over 9. Later, we are going to substitute these values into here, okay? But before that, right, let me just show you how a typical binomial distribution graph is going to look like when x is equal to 0. Because it is a discrete random variable, so the probability maybe it is of this kind of height. Then when x is equal to 1, it is going to adopt another height. So let's say something that is like this. When x is equal to 2, let's say I get something that is like this. In fact, the trend is going to be this way all the way until, I'm not sure, but somewhere where suddenly the probability will be at its peak. Okay, I don't know where it is. And after it reaches its peak, then it will start to fall. It is not going to be symmetrical, so I'm not going to draw it as a symmetrical, both left and right, okay? So I will have this all the way until the last few. So let's say this, and maybe the last one. The last one will be at 99, correct? Because the maximum possible value of x will be limited by the number of trials, and then the one that is before will be 98 and 97. So our aim, right, is to find what is this value of x that cause the probability to be the highest. How can I make use of this to find this? Because what you will realize, right, is that for this left-hand side here, hang on, let me use another color. For this left-hand side here, all the way until when the probability reach the highest possible, can you see the trend is that the probability will be increasing? Okay, this is the same for any binomial distribution graph, where the probability will be increasing until, it will be just consistently increasing until when it reaches the highest possible, which means that for here, right, it is when the probability of 1 is going to be less than the probability of the next one, k plus 1, where k is any value that is between 0, 1, 2, 3, and so on. Okay, so for this part of the graph, you realize that probability of probability of the number of success is going to be smaller than the probability of the next number of success that is bigger than the previous one. So probability that x is equal to k is going to be less than the probability of x is equal to k plus 1. Okay, and for this portion here, after the maximum possible probability is reached, then you will realize that the probability of x is equal to k, this one, is going to be more than the probability that x is equal to k plus 1. Okay, so there are two different trends that are going on. Before the most probable, one probability is going to be less than the next probability. After the most probable, one probability is going to be more than the next probability. So I'm going to be making use of this to try to find the most probable. And to do that, let me make use of this. Let me try to also substitute n by 99 and p as 7 over 9 first. So we know that p of probability of x is equal to k plus 1 divided by probability that x is equal to k. This is going to be equal to n, which is 99, minus k, multiplied by the probability, which is 7 over 9. And this is going to be divided by k plus 1, then 1 minus 7 over 9. If you were to do a quick simplification to this, I am going to be getting a 7 of 99 minus k divided by 2 times of k plus 1. Okay, so I've gotten this. How will this help me to find the most probable? Because of this inequality over here, I know that if I were to go for this, okay, if I were to let a probability, for example, probability that x is equal to k, be less than the next immediate probability that x is equal to k plus 1. If I were to let this be less than this, and because probability is always positive, probability is always going to be between 0 to 1, I'm going to divide this across to the other side, which means that I will get a probability of x is equal to k plus 1 divided by probability of x is equal to k. This is going to be bigger than 1. And what is this? This is 799 minus k divided by 2 times of k plus 1. Where this is supposed to be bigger than 1. And because k is 0 all the way until n minus 1, so k plus 1 times 2 is a positive number. Because I know it is a positive number, so I can multiply across the inequality. I'll get a 799 minus k is going to be bigger than 2 times of k plus 1. Well, this will tell me that k over here, let me see. This will tell me that k over here, I will have a 9k to be less than 691. So k over here is going to be less than 76.778. And k is an integer value that is from 0 all the way until n minus 1. So if k is also less than 76.778, this tells me that k will take out values like, for example, 0, 1, 2, 3, all the way until 76, correct? So k will take up all these values. What does this tell me about the most probable? This tells me that when k is equal to 0, when k is equal to 0, I have probability of x is equal to 0. If I were to substitute 0 into here, it's going to be less than the probability that x is equal to 0 plus 1, less than probability of x is equal to 1. And if k is equal to 1, then probability that x is equal to 1 is going to be less than the probability of x is equal to 2. And I can just go on and on all the way until when k is equal to 76. When k is equal to 76, it tells me that the probability that x is equal to 76 is going to be less than the probability that x is going to be equal to 77. And this is where it stops. In fact, it has already hinted to me that the maximum possible probability is achieved when x is equal to 77. In fact, this is my answer. X is, what is the most probable number of successes? 77. We can actually stop here. Okay, we are already getting our answers. My answer is x is equal to 77 because I see this trend and it ends at the highest possible probability, which is 77. But there are actually some other binomial distribution cases where you are going to be experiencing 2 modes. So for hello, this question that you're asking, right? We can explore this if we were to look at the other side of the binomial distribution graph. Okay, for example, right, I was saying, okay, for what you're asking now, right? Hello, as in like the person hello. This question. For what you're asking now, right, you can look at the left-hand side. Okay, like what I was saying, if you were to look at the left-hand side, you can see the trend of, if I were to look at this probability, it is going to be less than the next probability. And this probability is going to be less than the next probability, all the way until it reaches the maximum possible. And that's why this trend, probability that x is equal to k is less than probability that x is equal to k plus 1. Where this should be less than this when we are going from here all the way until here. Okay, so this is going on. Okay, when we go from here all the way until the last one, this will be what that is going on. That is why after you have let this be less than this, because you are analyzing this part of the binomial distribution graph, you deduce that this probability is going to be less than this probability is going to be less than this probability, all the way until when x goes to 77. That is why I know that for the most probable number of successes, where x is equal to 77, and this is going to be my answer. But you can stop here, like what I was saying. But what I'm trying to say, and the reason why I'm saying that you can stop here is because there is actually another possibility. It's not going to happen for this particular question. Another possibility is when you have 2 modes. Okay, this is what I'm going to say. If there were to be just 1 mode, but then this is, you just need to take care of one side. Okay, and if you were to look at NJC's solution, they only took care of one side. Okay, and that is because from experience, you can actually guess whether there's going to be 1 mode or 2 modes. We want one most probable or two most probable. What do I mean by two most probable? For example, right, it is possible for us to have something that is like this. This is the first one, second one, third one. Then we experience two modes. For example, what if I have this? So I have this number of successes and this number of successes that gives me the same probability. Then after that, the probability starts to decrease. It is also possible for us to experience two modes, but because you guys don't know when there will be one mode or when there will be two modes, so my suggestion is you do for both sides. You do for both sides. If, for example, for the other side you realize, okay, let's just do the other side first, okay, as a practice. So if I were to do both sides, for the other side, what should we do? For the other side, we are going to let probability that x is equal to k be bigger than probability that x is equal to k plus 1, correct? If we are doing this side, because this probability is bigger than the next probability. This tells me that the probability of x is equal to k plus 1 divided by the probability that x is equal to k. This is going to be less than 1, which means that 7 of 99 minus k divided by 2 times of k plus 1. This is going to be less than 1. And if you were to cross multiply again and then working out the range of values for k, if you were to do the same thing, you will end up with k to be bigger than 76.778, which means that what are the possible values for k? The possible values for k will be 77, then 78, then 79, all the way until 98. Why 98 and not 99? Because this relationship holds all the way until when k is n minus 1. So n is 99, so we'll go all the way until 98. And what does this tell me? This tells me that if k is equal to 77, I substitute it back into here. This tells me that probability that x is equal to 77 is going to be bigger than the probability that x is equal to 78. If I were to let k be equal to 78, it tells me that probability that x is equal to 78 is going to be bigger than probability that x is equal to 77. And all the way, and it's going to be bigger than all the way until when k is equal to 98, there will be probability when x is equal to 98 to be bigger than probability of the last one, which is x is equal to 99. So once again, we are seeing that it ends at 77 here and it starts at 77 here. So I know 77 is the mode. 77 is going to give us the highest probability. But if let's say you end at 77 and you realize that here you start at 78, which means that you're going to have two modes, 77 and 78. Oh, yep, my mistake. Okay, so this is 79. So, like what Claire you are saying, right? It is actually true. If you are not very sure whether there are going to be two modes, and I've seen cases where there are three modes. If you are not very sure how many modes there are, right, you should just work on both sides. But it is actually to be able to do a bit of prediction based on the n and based on the value of p that you are given. But because to you, right, you don't do this kind of question very often. So my suggestion is by default, you should just do both sides. Just to make sure, because when you do the other side, right, basically the process is just a repetition of the first part. So my suggestion is to just go for just both sides to determine that, okay, now I know from the result that I'm seeing here, right, therefore I can see that the most probable number of successes is going to be equal to 77. Yes, mode is like the largest frequency. And what is the largest frequency interpreted from the perspective of probability? it is also the one that has the highest probability, correct? Because the one that has highest frequency, when you take that number, when you take that frequency divided by overall, the probability is the highest. Okay, so mode is the one that is the highest frequency, which means that there will be highest chance of it happening, which means that it is also going to be the one that gives you the highest probability. And we can see from here, this is the highest probability. This is the not this. And this is the highest probability. Okay, but please take note that this question isn't asking us for the probability. This question is asking us for the value of x that gives us the highest probability. That is why my answer is 77, not the probability. Okay. It is a question that because in statistics, the way to study statistics is more of like trying to interpret the real life scenario, and then find ways to calculate the probability, the number of ways, and blah blah blah. So statistics is usually that. But once in a while, you see something that is a little bit more theoretical, a little bit more arithmetic, like for example, this question over here. And when you see questions that are like this, right, I would suggest that you go through it a few times. Just to get used to the algebra, so it's easier for you to try to execute in the exam. That means you treat this a little bit like pure math. Okay. My question to you, right, is that do you sort of understand what I'm trying to say now? Because if you sort of like know what I'm trying to say now, and you understand how doing this process is going to get you the most probable number of successes, then this question has went from a difficult question, potentially difficult question, to a pretty manageable question, and it will become an easy question if, like what I was saying, right, you can practice this question as if it is pure math. Because there are a lot of algebra, a lot of workings that are involved. Somebody said just now that this question is like tedious. Okay? All this gives you the impression that if you can just treat this as if it is pure math, practicing it a few times, you actually make this question surprisingly easy to be done in the exam. So my challenge to you, right, is that make this question an easy one for you. Then you don't need to care whether this is a difficult question or not. But if you plan to not study this question and you don't get the idea of this question, the idea of this question is based on the graph of a binomial distribution, then this will be a terrible question if you were to appear in the exam. So I would suggest that you learn this question first, because it can potentially become easy. And what if it comes out in the A level? We are not even talking about prelim. But then it will be such an advantage to us who now learn how to do a question that is like this, right? Okay, so I was saying just now, right, that when you're doing paper 2, start with statistics first. So I don't think this is the best possible experience when you start with statistics in general, because even if this question is an easier question, but it is still going to be more tedious than usual. So it may seem like a bad choice, but what if we were to continue and persist on doing statistics part of paper 2? Let's see question number 6. Okay, question number 6 is actually pretty okay. Most of the question in this section B is they are manageable. Okay, they are really way more manageable than the section A that we did on Tuesday. So now we have a group of 4 people. We have a group of 8 people, that consists of 4 married couple. They are supposed to be standing in a line. I want to find the number of different possible orders such that no 2 men are standing next to each other. We are going to do slotting. So woman, 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 woman. It is going to be 4 factorial. And for the husbands of the woman, they will be slotted here. And let's not forget the 2 ends. So we have 1, 2, 3, 4, 5 possible positions to slot the men. So 5 choose 4. Out of the 5 positions, we choose 4 for the men. And arranging the men 4 factorial. This is equal to 2, 8, 8, 0. 2 marks. Very easy to get 2 marks, because it is just something that you have studied basically out from your lecture notes. And on the Achevas TV, I also mentioned this, the slotting method. A fantastic method to make sure that objects are separated. Next, we are talking about this group now standing in a circle. We want to find the number of ways such that the men are going to be standing next to the wife. So the men standing next to the wife, we will have something that is like this, and we will group them together. So man standing next to the wife, we will group them together. So we can see it as if there are 4 objects permutated around a circle. So 4 minus 1 factorial. Within this, 2 factorial. Within this, another 2 factorial. So our times 2 factorial, our times 2 factorial, our times another 2 factorial. Or I can just simply see this as 2 factorial to the power of 4. This is equal to 96. 2 marks, 2 marks. I can probably get this within 1 minute, right? Because they are really very, very repetitive. It is a good choice. It is just going to be the best possible choice for a paper 2 to be started with statistics. Next, I want to form a group of I want to form a committee consisting of 2 teams, and the teams are going to have 4 people each. I want to find the number of ways such that for this committee to be formed such that the team will not consist of only men or women. And I think one quick way for me to do this is to make use of complement. So out of 8 people, we will just choose first, okay? So out of 8 people, we will choose 4, and out of 4 people, we will choose another 4 to form the committees. But this will mean that I'm trying to work on the first committee and the second committee, but it is just 2 committees that are identical to each other, so I'm going to divide it by 2 factorial. And this actually will consist of those scenarios where the committees consist of, the team consists of only men or women. But there are just 4 men, 4 women. So how many ways can I arrange them? So how many ways can I break them up into 2 teams of 4 so that there will be only men and only women? It's just one way. So I will just take this minus 1, and this is equal to 34. Well, let me very quickly repeat again. I'm doing a complement. So out of 8 people, we will choose 4 for the first team. Out of the next 4 people, we will choose 4 for the second team. But in this question, there is no first team or the second team. The 2 teams are basically identical. So I divide it by 2 factorial. And I'm going to minus away the number of ways such that the teams consist of only men or women. And since there are 4 men and 4 women, and we need teams of 4, there's only one way for this to happen. For teams to consist of only men or only women. So I minus 1. Where this gives me 34. A very quick and easy question. And that's it. Question number 6. Right, as compared to this, I think NJC had been fair because they set a pretty tedious question in 5. So they gave a more straightforward P&C question in question number 6. Then next, question number 7. We have written down my definition for the discrete random variables. Okay, for the random variables, so that I don't need to write all the words. Okay, but please remember, as part of your presentation marks, you need to be writing down this. In fact, it is not just presentation that makes writing down this important, but it is also you conveying the fact that you have identified the distribution, you have identified the condition for you to be applying the binomial distribution that we are going to be identifying. So for this, we have the employees trying to enroll in 3 possible programs. The first one is human resource. 29% of them will be enrolling in human resource. 100% will be enrolling in financial management, and the rest will be enrolling in Infocom technology program. We are working on 15 employees. And part 1, we want to find the probability that we're going to get exactly 12 out of these 15 employees who will be enrolling in either Infocom or finance program, just so that it's easier for us to discuss. Oh, I definitely am using a template. With my template, I will try to mention, if it is a binomial distribution, I will definitely try to mention n, the number of trials, and I will mention what exactly x represent, which means that in this case it is the number of employees that will enroll in the Infocom and the finance management. Okay, so x represent whatever that it represents, then out of the number of terms. So this is my general template when I try to define the random variable for binomial distribution. But I know some schools, they require you to write down one more thing. which is let X be the random variable that represents blah blah blah. Okay, so some schools they require you to write down the phrase random variable. So if your school require that, you make sure that you just write it down. Or in case you don't know whether you are supposed to write down let X be the random variable, then after that it is the same as what I've written here. In case you are not sure, my suggestion is just write down. You let X be the random variable that represents the number of employees out of 15 employees who will blah 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 blah. Okay, so what I'm seeing here is a binomial distribution out of 15 employees, and the probability of success that I'm looking at here are those who are enrolling in either infocom or financial management. And for human resource, the probability is 0.29. For finance management, let's say F. For finance management, it is 100 P%, so the probability is just going to be P. And then for infocom technology, infocom, let's say IC. Okay, for infocom, it will be 1 minus 0.29 minus away P. So this will be 0.71 minus P for infocom. And now we are talking about infocom and financial management, which means that anybody who don't enroll with for the HR program, so it's 1 minus 0.29, the probability will be 0.71. Okay, I got this by doing a 1 minus 0.29. And what the question wants us to do is to find the probability that X is equal to 12. And I just need to press this into the calculator. This is equal to 0.182 to 3 significant figures. Again, a very easy 2 marks to get. Next, I want to find the probability that there will be no less than 5 employees that will be taking up that will be enrolling in human resource program. So again, out of 15 employees, I'm using actually the same template where I'll mention what Y represent, and I'll mention about N, the number of trials, the number of employees. So what Y represents are those people who will be enrolling in human resource, and out of 15 employees, which means that for this case here, Y will follow a binomial distribution out of 15. The probability of success that we are looking at here, human resource, 0.29. And we are talking about no less than 5. So Y should be bigger or equal to 5. And because of the limitation of our Texas Instrument calculator, we are going to take 1 minus probability of Y is less than or equal to 4 to calculate this. And then pressing this into the calculator, we will be getting a 0.450, again to 3 significant figures. Next, suppose that now we are looking at 4 employees. So out of 4 employees, the probability of success is still going to be P. The probability of we are going to be writing down an equation in terms of P. P is the probability that someone is going to be enrolling in the finance management program. And the probability of either 1 or 2 employees saying that they are going to be enrolling in the financial program is 0.3. I want to try to write down an equation in terms of P and then try to find the value of P. So W here is once again going to follow a binomial distribution. Out of the number of trials 4, the probability of success is going to be P. Either 1 or 2 will be enrolling. That means I'm talking about probability that W is equal to 1 plus probability that W is equal to 2. And this probability, according to the question, is going to be equal to 0.3. Well, should we consider this as the equation that the question is trying to ask for? Because the question says, write down an equation in terms of P. I would suggest that you write down more in case the question says in case the question says write down the equation in terms of P and then they are giving you marks for it. Okay, I'll suggest that you continue some more, don't stop here as the equation. I'll suggest that you continue some more, substitute 4 and p into the formula for binomial distribution, which we did it just now. It will be 4 choose 1, and p to the power of 1 minus p to the power of 4 minus 1, plus 4 choose 2, then p to the power of 2, 1 minus p to the power of 4 minus 2. This is equal to 0.3. 4 choose 1 is 4. 4p, 1 minus p to the power of 3. Plus 4 choose 2 is 6. So 6p square, 1 minus p to the power of 2 is equal to 0.3. And in order for me to solve for p, I'm going to try to draw a graph. We to solve for the roots of the equation. To draw a graph to solve for p. But instead of drawing a graph of y1 to be equal to this and y2 is equal to 0.3, I'm going to bring 0.3 over to the left hand side, so that I just need to draw one graph, y1 to be equal to this. And the advantage of drawing just one graph is because I just need to see when this graph is going to cut the x-axis, instead of trying to find the intersection between this graph and the graph of y is equal to 0.3. I think this will reduce our careless mistakes. And I'm not saying that this graph is going to be very difficult to, I'm not saying that it is going to be very difficult to read for the value of p if you have to draw two graphs. But in the exam, to reduce any uncertainties, drawing one graph is usually better than drawing two graphs. And after I've drawn this graph, my suggestion is to produce this graph into your solution. You don't just write from GCP is equal to this. If you were to produce a table, if you were to use a table, produce that into your solution. If you were to use graph on your GC, produce that graph into your solution also. Do a quick sketch. For example, from my GC, right, I'm going to be getting something that is like this. Okay, I'll be getting something that is like this, where this number here, let me see. This number here is 0.08609. This number here is 0.72428. And this number here is 1.1979. So one of them is going to be equal to p. I'm definitely rejecting this because p is a probability, it cannot be more than 1. I'm going to be rejecting this also, 0.72. You know why I got to reject this? Because HR is 0.29, which means that 1 minus 0.29 is 0.71. And p cannot be more than 0.71, right? Because the total of all the probabilities should be equal to 1. So p must be less than 0.71, less than or equal to 0.71. Okay, so, and I'm getting a p that is more than 0.71, so I'm going to be rejecting this. My answer is going to be this. So p is going to be equal to 0.08609. I'm going to go for this. Or p, according to the graph that I've gotten, right, is this, which I'm going to be rejecting. Maybe I should write a reason. Rejecting because p should be less than 0.71. Or p, in this case, 1.1979. It is easy to find a reason to reject this because p should be between 0 and 1. Therefore, I know p is going to be equal to 0.0861. Okay, there should be a 0 here to 5 SF. Can show my working on the GC. Yes, I do have a screenshot of that, I think. Let me see. Okay, I press this into the Y1 of my GC. Then my graph is this. Okay, my graph is this. and I'm looking for those places where it cuts the x-axis here, here, and here. So this point where it cuts the x-axis, 0.086090. Okay. Let's see, is there anything else that I think I can discuss about this question? No, I think that's it. This is a pretty okay question. So we are at our third question. The first question was tedious, but if you have spent time practicing it, then it is pretty okay, manageable, I think. The second and third question that we have done so far, they are pretty okay. So insert window. Yes, you know, I changed the window. I think for this I just did a zoom where I didn't press window to set the x minimum, x maximum, y minimum, y maximum, where I just do a zooming and I got this. And like what I was saying, right, if you were to be drawing just one graph, we bring the 0.3 over to the left hand side, there will be less hassle because you are just simply working on the roots of this graph, which is the places where it cuts the x-axis. So to get this, I zoom, but I didn't set between 0 and 1. You can see from my graph here, right? Wait, 0 is here. 0 is here, 1 is here, so I didn't really set that. Quartic graph, yep, this should be a quartic graph because it is p to the power of 4. So it should be a quartic graph. I can see from this side, right, the graph turns back up. So it is probably going to be something that is like this. For graphs that is like this, I'm not sure whether you are supposed to. This is really a super huge, super huge power. But in case you are trying to solve for some answers through this graph, right? Like what I was saying, if you can just bring everything over to one side, and then try to draw one graph, maybe it is easy enough for you to find the root. Actually, the root of this is just x is equal to 1, right? So okay, I'm not sure what is the aim of this question really, but I mean, as to be laughing at this, right? To be laughing at this, I guess it is really because we study math, or else somebody who doesn't study math, I don't think they will find this funny. But I do find this funny because the power is like 113. It's like super big. I don't know. Okay, let's continue. Question number 8, a discrete random variable question. So there are k envelopes, and for these k envelopes, Joe is going to be opening up just 3 of them. And for this k number of envelopes, 3 of the envelopes contains $1, and the rest of them contains $10. So X represents the amount of money that he is going to be getting after you have chosen the 3 envelopes to open. Okay, so this is the amount of money that Joe can possibly obtain. I want to find the values of A and K. We need to do a bit of observation to find A, because this is a probability. This is a probability distribution table for X, which means that what that we are seeing here, the numbers represents all the possible cases. So if there were to be K number of envelopes and Joe can pick just 3 envelopes, and the envelopes can only be either $1 or $10, I guess to get 3, it will be when Joe pick $1, $1 followed by $1, correct? To get 12, Joe will be doing a $10 plus a $1 plus a $1. And to get a 21, Joe will be doing a $10 plus $10 plus $10 because he can only open 3 envelopes. So is there any other cases that we can think of? oops, I've already written it down. So it's 10 plus 10 plus 121. So the last possible case is 10 plus 10 plus 10. So from my observation for part 1, I guess A is going to be equal to 10 plus 10 plus 10. This is equal to 30. Then K is the number of envelopes. I'm assuming that for some of you, you probably can observe that K is equal to 6, because when it is $3, when it is $3, we have already exhausted all the 1, we get this probability. And when it is 10 plus 10 plus 10, we are getting exactly the same probability. So, and there are 3 1s, which means that there is probably going to be 3 10s. That is why K should be 3 plus 3 is going to be 6. This is if you were to do an observation, since they share the same probability. Or else you can also do a quick calculation. For example, 0.05 is obtained by to obtain $3, right? The probability is 0.05. And that is when the first envelope that you open contains 1, so 3 over K. The second envelope also contains $1, so 2 over K minus 1. And then the third envelope contains $1 also. The probability is going to be K minus 2. And this is equal to 0.05. If you have to draw a graph to solve for K, you're going to get K to be equal to 6. Yep, K is going to be equal to 6. So let me write it down here, okay? So now we have deduced that this A here is equal to, we've deduced that this A here is equal to 30, and K here, this is equal to 6. Part 2, part 2, let me just write down for you what NJC says in their solution. How can we explain about the concept of randomness in the context of this question? Let me just copy it down for you, okay? NJC said something that is like this. Which means that the randomness is there, okay, because there's a equal chance of every envelope being opened by Joe. Next, part 3. Part 3, okay, from the first part, right, we are talking about Joe playing one game. Okay, in part 3, Joe is going to be involved in n number of games. And we are going to be looking at the mean amount of prize money that Joe is going to be receiving. So for one game, it is X. For n number of games, and we are talking about the mean of n number of games, we are talking about X1 plus X2 plus X3 plus all the way until Xn divided by n. Okay, so this is the mean amount of money that Joe is going to receive. And we will require a distribution to We'll require a distribution to represent this so that we can calculate the least possible value for n by making use of the probability that is given to us. The probability that the mean amount of money that Joe received is going to be greater than 0.95. So we need a distribution for this, and since n is bigger or equal to 20, I know 20 is not very big, but at the same time, right, in order for you to continue with this, you need to approximate this via the central limit theorem to form a normal distribution. That is why, like what I've mentioned in one of the other sessions, one of the other live streams that we had, right? Sometimes when you see numbers that are like this, which is obviously not the same kind of numbers that is in our school's notes. Our school's notes quote like 50, some school's notes quotes like 30, but 20, we are just going to assume it as large. It is not that smaller, okay? So I'm going to just assume it to be large, which means that we are going to be making use of the central limit theorem. So we need the expectation of x, and we need the variance of x. So let's try to find the expectation of x. The expectation of x. This is going to be summation of x multiplied by the probability that x is equal to x. So this is going to be 3 multiplied by 0.05 plus 12 multiplied by 0.45 and 21 multiplied by 0.45 and 30 multiplied by 0.05. If I were to press this into the calculator, I'm going to be getting a 16.5. This is the mean this is the mean of x, and we want to find the variance of x. So let's first find the expectation of x squared. This is going to be summation of x squared multiplied by the probability that x is equal to x. So this will be 3 squared 0.05, 12 squared 0.45, then 21 square 0.45, and finally 30 square 0.05. This will get you a 308.7, which means that the variance of x which is expectation of x square minus the expectation of x square. This will be 308.7 minus away 16.5 square. This is equal to 36.45. This will help us to form a distribution for this, which I'm going to give it as a notation x bar. So x bar will follow a normal distribution with the mean of x 16.5 and the variance of x 36.45 divided by the sample size, which is n, and this is by the central limit theorem. Since n, which is bigger or equal to 20, I'm going to be considering it as large. And according to what the question says is that when this mean is within $2, so we are talking about x bar minus away within $2 of the expected amount. The expected amount is this. Okay, the question says the expected amount of money. The expected amount of money is this. So for x bar to be within $2 of the expected amount, it is when this minus 16.5 is less than or equal to 2. And according to the question, this must be bigger than 0.95. So it is the probability when x bar minus 16.5 is going to be between minus 2 and 2. Which means that we are basically just looking at x bar to be between minus 16.5, bring it over to the other side, 14.5 and 18.5. And I'm going to just press this into my GC. Let me show you what I have on my graphing calculator. Did I? Oh, yep. So I'm going to press this as into the Y1 of my graphing calculator. Okay, and generating for myself a table. So I'll press this with n represented by x, and I'm going to get a table which is this. My table will be n, and this is going to be the probability that x bar is between 14.5 and 18.5. So if I were to scroll down my table, you realize that when n is equal to 35, this probability is 0.95. Not what I want, because I want something that is bigger than 0.95. When it is 36, the probability that I'm getting is 0.9531. Okay, this is what I want. When it is 37, I see the same trend, 0.9561. Therefore, the least possible. is equal to 36. Okay, also a pretty simple question, I think. Especially when this question has already made it obvious that we are going to be applying sample mean distribution. That's why indirectly they are hinting to us that we need to find the expectation of x and the variance of x. Other than this, I think in general this is a manageable enough question. And even if we didn't get the hint that we are supposed to find expectation and variance, seeing that this is a discrete random variable question, I will probably still just go and find the expectation and the variance. Well, at least I can get about 3 marks for this, right? In most of the exams, for marks allocation wise, the expectation is going to be 1 mark. Then the expectation of x squared is going to be 1 mark. And the variance is going to be 1 mark. So as a default, I know going through this process is going to get me 3 marks. Next, let's see. Okay, correlation linear regression, we are going to skip. Let's look at the next. 10. 10, I actually struggle a little bit understanding what the question is talking about. But it is okay. It is not that bad, but we do need some time to process the question, I feel. And I can remember last year, my NJC student did ask me about this question before. So the feedback was about interpretation, not so much of the calculation, because I don't think the calculation is that difficult. Maybe it's a little bit difficult for part 2, but they ask you to show. So even if you didn't manage to find part 2, right, you probably should be able to find part 3 and part 4. A little bit of pure math, but it's not too bad. So we have T0, where the result is going to be where we are going to be getting a negative result. T1, we are going to be getting a positive result. S is when a patient has heart disease. S prime is when a patient has no heart disease. And we are given this set of information in terms of notation. Ti given S. Ti given S prime. And when I is equal to 0, I'm getting this, which means that this probability here, 0.42, is a representation of probability where T0 given S. Okay, because I is equal to 0, which means that Q2 over here is probability of T1 given S. Similarly, Q2 here, when I is equal to 0, we are talking about probability of T0 given S prime. And this is probability of T1 given S prime. And we are supposed to find Q1 and Q2. What we can try to do is to build for ourselves a tree diagram, starting with S and S prime. For example, if I have this S and S prime, according to this, right, if someone who, according to the information that is given, we are testing people who can potentially have this heart disease. So the person will be going through test, and the result can be negative, the result can be positive. The same for someone who has no heart disease, the result can be negative, the result can be positive. And according to the question, for those people who has heart disease, T0 is 0.42. So for those people with heart disease, to get T0, this is 0.42. To get T1, this is Q2. Similarly, for this, it tells me that for those people who has no heart disease, the probability of the test being negative is Q1, and for the test being positive, this is going to be equal to 0.04. And if you were to look at this, since these are the only two branches coming out from S, that means I know 0.42 plus Q2. When I add them together, it should be equal to 1. This tells me what is Q2. This is going to be equal to 0.58. Similarly for this, I know 0.04 plus Q1. This should be equal to 1. This tells me that Q1 is equal to 0.96. Okay, So this will be the two values for Q1 and Q2. Let me jot it down here. So Q2 is this. So this is equal to Q2. Q2 is 0.58. And Q1, this is equal to 0.96. But I do think that this question is difficult in terms of both interpretation and a little bit of manipulation and calculation. So we would have gotten a bit faster in the previous two questions, previous two questions, and then we will be slowed down a little bit here and see whether we can pick up pace again before we do 11. 11 is a hypothesis testing question, which is actually pretty decent, not exactly easy, but it's not a difficult question too. This is part 1. Let's take a look at part 2. Really? This is the O-level type of question? I thought this is quite difficult because of the interpretation, the conditional probability. But if I've managed to interpret the conditional probability, then yeah, this is a pretty okay and easy question. I want to show this probability of S given T naught, T0. We want to show this is equal to this expression. Okay, when I'm given that PS is equal to P. So this is probability of S and T0 divided by probability of T0. And we need to find clues to help us to find probability of S and T0. And then hopefully we can also find hints that can help us to calculate the probability of T0. But of course, one hint that I know I can make use of is already this. Probability that S is equal to P. I'm not sure how I can use that yet, but where are the rest of the places that I can find hint? S and T0 is in the numerator. So I guess I am going to try to find all the S and T0 probabilities that are given to me, which is this S and T0. Do I have any more S and T0? I guess another place that I can try is this. Well, at least there's a T0, and I don't mind S because probability of S is P, so probability of S prime will be 1 minus P. Well, let's see whether we can make use of this too. So first of all, let's see. I think I can make use of this. That means probability of T0 given S. Okay, this is equal to 0.42. That means probability of T0 and S divided by probability of S. This is equal to 0.42, which means that the probability of T0 and S, this is 0.42 multiplied by the probability of S, which is 0.42 multiplied by P. This will give us the numerator. Let me write it down here. So numerator 0.42 multiplied by P divided by the denominator. And again, we are looking at T0. So T0, we have this T0 here, we have another T0 here. So let's see whether we can make use of either of this. To be making use of this, I've already come up with something that is like this. T0 and S is 0.42P. Let's see what we can do with this. So this T0 given S prime. Let's try probability of T0 given S prime. And please take note, I'm picking out specifically these two, right? Because it involves T0. Okay, I'm looking at T0 in the denominator. Okay, I can't possibly use these two, and there's no other pieces of information that is given to me also. Okay, that's why I am working specifically on this. Okay, I didn't do this randomly, okay? So this, which is what I'm writing down now, this is equal to Q1, and we have found out that Q1 is 0.96. So this is P of T0 and S prime divided by the probability of S prime. This is equal to 0.96. So P of T0 and S prime, this is equal to 0.96 multiplied by the probability of S prime is 1 minus P. And if you think about it, right, now we have this result and we have this result. if I were to just try to visualize this on a Venn diagram, it will actually get sort of like obvious. If I were to work on two events T0 and S, what is T0 intersect S? T0 intersect S is this part. So this is 0.42 p. What is T0 intersect S prime? T0 intersect S prime is this portion here, which is 0.961 minus p. So now we have a total of T0. That is why this T0 in the denominator, I can actually break it up into probability of T0 intersect S plus probability of T0 intersect S prime. So it is going to be equal to 0.42 p divided by this, which is 0.42 p also, plus this, which is 96 1 minus p. So we have a 0.42 p divided by 0.96 minus 0.54 p. Okay, Claire, you are asking, right, that letting this be equal to p and letting this be equal to 1 minus p, and working through the tree diagram, okay, I'm not sure what is your plan in working through using this p diagram, but please take note that 1 minus p times 0.04 is not, that means this number, for example, if you take this number multiply by this number, it is not S and T1. With this number multiply by this number, oh, actually it is, yeah, actually I think you can use the tree diagram to try to work through this part, which is going to be 0.42 p. But T0, I don't think you can make use of the tree diagram. So you probably will need to go through this. But of course, if you can see T0 as this, then you can work through the tree diagram again. Then from here, we are supposed to prove that it is 7p divided by 16 minus 9p. So I'm going to just try, okay? That means I'm going to just try to see whether I can immediately manipulate this to 7p by going for a 7 over 0.42 divided by 7 over 0.42. I mean, this will just make it fast. I mean, if I'm correct, right, I should be able to get this number, and I'm actually going to be correct. So if you were to take this multiply by this, we will definitely be getting a 7p. And if you honestly try to take this multiply by this, you will indeed be getting a 16, then minus 9p. Okay, which is what the question wants you to show. Okay. And I think probably that is the most difficult part of the question. Okay, part 1 and part 2. Then after that, it should be pretty okay. Let me remove this first. I'm going to remove this, and I'm going to do part 3. I think I'm going to remove this also. Okay, let me start with this. We have a p of s given t0. This is equal to 7p over 16 minus 9p. And in part 3, we are supposed to differentiate this and show that it is an increasing function with respect to p. So let's try to do a differentiation, dp, of this p of s given t0. So we are going to be differentiating this with respect to p, quotient rule, 16 minus 9p multiplied by 7 minus away 7p multiplied by minus 9. This divided by 16 minus 9p squared. In the numerator, you will be getting a 112 minus 63p, then plus 63p divided by this 16 minus 9p squared. So we are getting a positive expression. The numerator is 112. The denominator is 16 minus 9p squared. And this is always bigger than 0. Therefore, we can say that probability of s given t0 is an increasing function. And can you explain this statement in the context of this question? I mean, this is a little bit awkward, but it is literally just like regurgitating your pure math. For example, if I were to see this from the perspective of pure math, it is when p increases, we see that probability of s given as 0 increases. Okay, so from what we have learned in our pure math differentiation, when p increases, this quantity increase. So I just need to talk about this whereby replacing the notation with words. You usually score the marks for this kind of question. So I'll say something that is like this, okay? So when p, what is p? P is probability of s. So it is the event when the heart disease is present in the patient. So when the probability of a patient having heart disease, for example, increases, whereas the probability of a patient having heart disease increases, I will just say that this increase. So what is this? This is the probability of a patient having heart disease given that the test was negative. Having heart disease given that the test result increases. So that's it, okay? It is really very, very literal. You just basically need to replace the notation with whatever that the context of the question says. As p increases, probability of s given t0 increases. And I really thought I should write down this for you guys because to me this can become like sort of like a template for next week if you are still going to be having your paper 2. That means when you are seeing a notation being used and then they ask you to yet still give the meaning of the notation, right? Most of the time you just need to recite it based on what the notation is defined through the question, then you should be able to get the marks already. Yeah, I mean the reliability of this test, we can see someone not having a heart disease, but being tested as positive is 0.04. All tests has a certain level of unreliability. So that's what this question is trying to say. That is part 3. And for part 4, now p is equal to 0.3. Okay, now p is equal to 0.3. And the patient is now going to go through 2 tests. When it is given to me that the patient is going to be tested positive twice, I want to find the probability that this patient has heart disease. We are talking again about conditional probability. It's just that now the patient is going to go through the the test procedure twice, and twice we are going to be getting a positive. That means if I were to go back to my tree diagram, right, we can view it as something that is like this. Heart disease, no heart disease. The probability of having a heart disease now is given to me as 0.3. So here it's going to be 0.7. The test can be negative or the test can be positive. And we are talking about the test being positive twice. So test positive and test positive. According to the previous part, right, probability of T1 given S, probability of T1 given S is 0.58. So here is 0.58, and T1 given S, it will be 0.58 again. So we have a T0 and a T1 and a T1 again. T1 given S prime, T1 given S prime is 0.04. So this will be 0.04. This will be 0.04. And we are working on the probability that someone has a heart disease. Given that the person is going to be tested positive twice. So for the numerator, having heart disease and being tested positive twice, it will be 0.3 multiplied by 0.58 and multiplied by 0.58 again, divided by the probability that someone being tested positive twice. It will definitely be someone having heart disease and being tested positive twice, or the unreliability is going to be this: someone having no heart disease but being tested positive twice. And this is going to be equal to 0.989. Okay, question number 10. Okay, and one last question, question number 11. So I think question number 5, the first question that we did, and this question number 10, where both of these questions will tend to slow us down. The rest of the questions are pretty okay. So I do still think that you should try to aim to, I mean, in case some of you are going to be trying to redo this part again, I think you should try to aim to finish this within 1 hour 30 minutes. Right, knowing that you're actually not going to be doing the correlation linear regression question. So 1 hour 30 is definitely it's definitely a good time, and you should aim to cut off by 1 hour 30 and then moving on to the pure math portion. So now we have these personal mobility devices, and it really depends. I can't really say that there is a good way for us to identify conditional probability, because, like, for example, you saying this, right, is you're already trying to memorize the word given, which is not the best possible way to identify conditional probability, because the English can change, but the idea must be the same, the meaning must be the same. So usually what I will do is I will try to see whether I see two events. But when two events happen, there can be three possible cases: A union B, A intersect B, A given B. If it is A union B, the English will usually be phrased in such a way that it is A or B. If it is A intersect B, it will usually be A and B, which is the one that is pretty confusing when we try to compare it to A given B, when I'm not given the word given, So the problem is usually when it is A and B, A given B. I don't have a perfect way for you to distinguish between these two when it comes to the language. No matter what, it depends on the way that we interpret the English. But a small little rule that you can try, okay, which may not be 100% successful, is when you are seeing two events, A, B, if they were to ask you for the probability of one of the events, instead of asking you for the probability of the other. But there is still one more event that occur, together, okay? It's just that they are asking for the probability of one of the two only. Then there's a good chance that it is a conditional probability. Like for example here, right? Okay, can you see that there are two events? One is tested positive twice. This is one event. Then the other one is patient having heart disease. And can you see that they're actually interested in the probability of a patient having heart disease? But somehow there's one more information that is given. And this information that is given comes along with this as a fact. But that is how we can guess. If you cannot interpret it that it's a conditional probability, we can still try to guess that it is a conditional probability. Okay, two events where they're asking you for one of the two events, and then the other event is given to you. Somehow it was just there. Okay, so usually this kind of case you can try, you can try to see whether it is a conditional probability. Let me see whether there's another scenario that is something similar to this. I thought there are okay. I think this is this is one good place. This is one good place where I can show you this. But I can try. It actually works almost all the time for myself. Next, let's look at the last question here. So we have this scenario that is given. We are supposed to, okay, and the speed limit is given to me as 10 km per hour. When the citizen believe that the speed has increased, the belief that the speed limit is exceeded, so more than 10 km per hour, we are going to be testing this belief using 250 PMDs. And for these 250 PMDs, the information is summarized here. So part 1, we are going to be calculating the unbiased estimate to the population mean and the variance. So part 1, the unbiased estimate to the population mean is going to be calculated by X bar. So this is going to be summation of, since this is the way that the information is given, I'm going to use the formula that I've quoted on the Achevas theory outline under sampling theory. So it is this divided by n plus 10. So it is 38.9 divided by n 250 plus 10. This is equal to 10.1556, which I'm going to be using later. So I'm going to approximate to 3 significant figure as my answer, 10.2. For part 1, I'm going to calculate the unbiased estimate to the population variance. So the population variance, I'm going to be using this notation. The unbiased estimate is this. And I'm going to once again make use of the same formula that I've used on the Achevas TV theory outline under sampling theory. This is going to be summation of x minus 10 square minus away summation of x minus 10 square divided by n. This is 1 over 250 minus 1. Then this is 390.31 minus away 38.9 square divided by n, 250. This is equal to 1.5432. Okay, so this is my answer. Next, part 2. Part 2, let's test at 4% level of significance for the belief. The belief is that the speed limit is going to be exceeded. So H0 is when mu is equal to 10. H1, the alternative hypothesis, is the belief that the speed limit has been exceeded. The number of samples that we are using is 250. The evidence that we have collected shows us that the sample mean is this 10.1556. We will also need the population variance. And if you were to read the question, the population variance is not given, So I'm going to compromise by making use of the unbiased estimate to the population variance. We've calculated it here, 1.5432. So this will allow me to code my test statistics. My test statistics will be working on x1 plus x2 all the way until x250 divided by 250, which I'm going to use this notation x bar. So this will follow a normal distribution with the population mean and the population variance divided by the sample size, 250. And if you were to look at this question, it has never been mentioned to me that the speed limit follows a normal distribution. It is not mentioned, so in order for me to write this as a normal distribution, we'll be approximating this through the central limit theorem. And this was possible because n, which is equal to 250 as compared to the 20 that we looked at just now, is definitely large. So I'm going to press it into my GC to get the p-value. Bayes' theorem for conditional probability, I've totally forgotten the Bayes' theorem, so I cannot comment anything, okay, Claire? I think the last time when I learned it was, the last time when I saw it was, I think maybe 7 years ago, so I have totally no idea what it is already currently. I am going to be pressing this into the calculator. So this, after I press this into the calculator, I will be getting this, where I'm going to be extracting out the probability. They say it assumes. Hang on. You mean the question says that we are assuming that it follows a normal distribution? Goodness, I cannot see. Oh, yes. I'm so sorry. Yeah. Where the question says the speed of the PMD follows a normal distribution. Okay, goodness, I'm wrong. If I were to be quoting this in an exam, I'll probably get 1 mark minus off. So I shouldn't be quoting this. So let me remove this, okay? Since the question already tells me that it follows a normal distribution. So, oops, why is it not working? Okay, oops, not this. I must remove this. Okay. So I'm going to press this into my calculator, and I've just shown you a negative example. We cannot quote central limit theorem when it is not necessary for us to do that assumption. So from my calculator, we can find the p-value. The p-value here is 0.023825. Okay, actually I can remove this. I'm going to remove this also, okay? So I'm going to write down my conclusion. Since this p-value that I'm looking at, since this p-value we are looking at 4% level of significance, so since this p-value here is less than 0.04, there's sufficient evidence that the speed limit has increased at 4% level of significance. Okay, then part 3. Part 3, yeah, a typical question. What is the meaning of 4% level of significance? It means that there is a probability 0.04, that the speed limit is wrongly believed. To have increased when in fact it has not. Okay. Without doing any further test, can we make any, explain the conclusion in part 2, or explain whether the conclusion in part 2 will change if we are testing that it is not 10 km per hour instead. In part 2 we are testing that it is more than 10 km per hour, and what if we are changing it to not? It means h naught will be mu is equal to 10, and h1 we're going to go for mu is not equal to 10. When all the other conditions remain the same, will this lead to a change in our condition, a change in our conclusion? When we go from a one-tail test to a two-tail test, the p-value is going to be doubled. So the p-value for this two-tail test is going to be 2 times of the previous p-value. This is 0.023825. This is equal to 0.04765. This is bigger than 0.04. So from sufficient evidence, now there is going to be insufficient evidence. So there is insufficient. This tells me that the conclusion will change. Let me just write conclusion change. Wait. So part 4, the conclusion will change, and one last part. 3 months later, another investigation was done to look at the mean speed of the PMDs, and we are looking at the mean speed to differ from the regular speed limit of 10 km per hour, so not equal to, we are doing a two-tail test, and another large sample, so n is large. It is already given to us by the question, and it is found that the sample mean is 9.5 and the sample standard deviation is 3.2. We want to find the smallest possible n such that at 5% level of significance, we will be rejecting h naught. We will be able to conclude that the mean speed limit has differed from 10 km per hour. Okay, let me erase this. So now in this last part, so for part 5, we know h naught is still going to be, mu is still going to be equal to 10, and h1 is such that mu is not equal to 10. N is an unknown, which we are supposed to find the smallest possible value of. X bar is given to us as 9.5. We need the population variance, and again I'm not given the population variance, so I'm going to estimate through the unbiased estimate to the population variance, and the formula that I'm going to be using is n over n minus 1 multiplied by the sample variance. So we have a n over n minus 1. The sample variance is going to be 3.2 square. So this is equal to 10.24 n over n minus 1. And with this, we can now write down the test statistics. And for the test statistics, x bar will follow a normal distribution with 10, and the variance will be the population variance, 10.24n over n minus 1 divided by n. With population variance divided by n, and this time I'm going to be quoting the central limit theorem. Okay. Then according to the question, at 5% level of significance, we are supposed to find sufficient evidence to reject H0. So, to be rejecting H0 as a two-tailed test, to be rejecting H0 as a two-tailed test, oh, maybe I should, hang on, I think I should just simplify this first. This looks like a huge expression, an unnecessarily huge expression, so I'm going to rewrite this as 10.24 over n minus 1. Okay, it looks better. So again, I was saying this question tells us that we are supposed to be rejecting the null hypothesis as a two-tailed test based on my test statistics, this probability here. I know the center here is 10. We are talking about 5% level of significance, and as a two-tailed test, that means this 5% level of significance will define for us the critical region as a 0.05 over 2 on the left hand side and a 0.05 over 2 on the right hand side. And because the rejection is happening, so 9.5, which is smaller than 10, should be within this critical region. So 9.5 is here. And if I were to look at the area that is on the left hand side of 9.5, we can see that the probability, the area which is the probability of x bar, is less than 9.5. This area is less than 0.05 over 2. And if I were to standardize this, I will have z to be less than 9.5 minus away 10 divided by square root of this whole thing, which is 10.24 over n minus 1. This is less than 0.025. If I were to press it into my calculator, I will be getting a negative 1.9600. So 9.5 minus 10 over square root of 10.24 over n minus 1. This is going to be less than negative 1.9600. So the square root of n minus 1 is going to be, what is that? It's going to be bigger than 12.544. This tells me that n is going to be bigger than 158.35. And so what is the smallest possible n? N is a sample size. So if n is bigger than this, that means the smallest possible n will be 159. Yay. We have finished.